Dear all participants, kindly join for 5 minutes. Wait for 5 minutes. Sir is joining the meeting. Sir Santosh sir.
Yes, ma'am. Good evening.
Sir, very good evening, sir. Just a minute, sir. Yeah, we are starting the session right now. So a very good evening to everyone. We warmly invite you all to the day for. Just on the video. A very good evening to everyone. We warmly invite you all to the day 4 of the AICT Training and Learning ATAL sponsored faculty development program on Joy of AI in Action, applying traditional and agentic AI to real world problems, scheduled to be held online from August 18th to August 23rd, 2025. We are truly honored to welcome our today's speaker of the first session, Dr. Santosh Kumar Sahu sir, to our ATAL FDP program. Dr. Santosh Kumar Sahu is working as a programming officer in Oil and Natural Gas Corporation, ONGC Limited, India. He is currently working in Geodata Processing and Interpretation Center, GeoPIC, a premium R&D institute of ONGC at Dehradun, Uttarakhand. He received a PhD degree from NIT Rourkela, Odisha in Computer Science and Engineering. He has 5 years of experience in research on oil and gas industry and 3 years of experience in teaching. He has published many papers in reputed international and national journals and conferences. His research interests include cybersecurity, data mining, reverse engineering, and digital forensic. Thank you, sir, for joining our today's program. Over to you, sir.
Thank you, ma'am. Good evening, all of you. Let me share my screen. Today, we will discuss about applied machine learning techniques to design fast AI/ML prototypes using Orange data mining tool. Am I audible, ma'am?
Yes, sir, it's audible,
Yeah.
sir.
So, we will discuss data pre-processing, modeling, image analysis, and followed by XI techniques. So, if you have any doubt during the session, please feel free to ask. And you also work along with me. Just I will show you. First, you download the tool. You go to Orange Data Mining portal. This is the URL for Orange Data Mining Tools portal. You just visit the portal and go to download and download
Hello,
the tool first.
sir Santosh, sir.
Ma'am.
Presentation is not coming, sir.
Kindly visit the site. Yeah, first you go to Google. And in Google, you type orange data mining, orange data mining tool, and go to download section. And if you are using Windows, then there are two versions are available. One is standalone and second is portable. So you download either one, either a standalone installer or portable. If you download standalone installer, then you should install first and then you can use. But by using the portable, we simply extract and use Orange. Let me show you. I have downloaded the portable version. So let me show you how to open the portable edition. No need for any installation. You simply extract and use it. And the beauty of this tool is without administrative privilege, you can use it. In our universities and industry, especially the pieces which are allotted to us, uh, we have no administrative privilege due to security issues. So we are not able to install any executable file, but yeah, in case of Orange, no need for any privilege, any administrative privilege to install the tool. You simply double click, next, and finish. It will install. And in case of portable edition, you simply extract it and it will work. I just I'm going to show you how to use it. After extract the archive file, you simply double click the Orange shortcut and Orange will open. Okay, and we can directly interact with the Orange dashboard. Okay, so before that, you simply start download, and along with me, you please use your own data, and we will also use some public data sets during the discussion. So let me discuss why we will use Orange. Why not Python or any other programming language? So as you know, Orange is a visual programming language. Means visually we can use the widgets to connect. Widget means graphical objects that can connect as per our requirement, and then we design the AIML prototype. आपको जो बनाना है, means whatever your task is, accordingly suppose it is supervised or unsupervised or semi-supervised, as per your task you can design it without writing a single line of code. Okay, that means by using mouse we can design our prototype very faster. Means to simulate a supervised approach, you require hardly 5 to 10 minutes. Okay, and for statistical analysis you also require 2 to 3 minutes. Okay, to check the data, means if, how the data is looking like, what is the histogram, what is the means what are the class distribution. Okay, and what is the minimum maximum value present in the columns or features. Similarly, whether some missing information is exist or not, ये सारे एनालिसिस आप विद इन 5 मिनट आप कर सकते हैं यूजिंग दिस टूल, एंड इट इज ओपन सोर्स, नो नीड टू परचेज, एंड it is another advantage is it is compatible with Python. So if you know Python, then you can extend the capabilities of this tool. Okay, we will discuss one by one, and it is very helpful for faculty members as well as the research scholar to demonstrate, to understand different data mining phases, and during the modeling you can use this tool. And especially in case of laboratory, means for data science lab, this is one of the excellent tool to visualize all the concept to your students with a minimum time, and it is very simple but effective. And if you know Python, then we can extend its capabilities. So we will discuss one by one. So Orange is not a single tool. There are so many tools are available. Some are commercial and some are open source. So we will not discuss the commercial tool, but open source, you can use Canine, R Studio. If you know R programming language, then there is a GUI for data science. Its name is Rattle, RATTLE, Rattle. And Rattle also is like Orange, and it generates the R code. Okay, but in this discussion we will discuss Orange and Python. And another tool is Weka. If you know Java, then Weka is very helpful for you. Same thing, like Orange with Python, yeah, R with Rattle with R, or your Weka with Java. So as you means as per your expertise, you use the tool and use to design your prototypes using the visual programming tool. All are visual programming tools. Okay. Now I have already told you why Orange. So let me show you the different data mining phases. Okay. So the first phase, we will not discuss the data acquisition part. We will use some data sets, some open source data sets available in UCI repository that is directly downloaded using Orange. I will show you. And then we will apply some data pre-processing technique, feature selection, feature reduction, modeling, and validation. Deployment we will not cover because for deployment we should use Python. So now we will discuss how we can use Orange for data pre-processing. Okay. Means how to examine the data, how to fill the missing values, how to detect and remove the duplicate records, then outlier detection and standardization. ये सारे that all are covers under data pre-processing that are crucial and for each and every problem. It may be your image processing, or it may be any other field like test analysis or tabular data analysis. Each and every problem, one solution is data pre-processing. That will be you have to spend 70% of your effort for data cleaning part. Okay, so as much you process your information, accordingly your model will behave. Okay, and if your data is clean, there is no inconsistencies in your data, and you follow all the steps properly, then you definitely get a better result. You will skip it right now. Let me show you the Orange dashboard. So after double click the shortcut, यहाँ पे जो shortcut था, after double click the shortcut, now Orange will open and see. This is the main dashboard of Orange. And the dashboard divided into two parts. The leftmost part is known as the toolkits or widgets collection. So what is widgets? Now widgets are the graphical objects that are used to, that are the graphical component, or you can say that these are the building blocks of to design the Orange workflow. Okay, so AI/ML का जो भी आपको workflow draw करना है, for that reason you should use that objects. Okay, and that object is known as widgets. Like this is the data collection widgets, and under this data there is a file widget, CSV import, data sets. Okay, what is file widgets? I just magnify it. File widgets is used to import a file. Okay, आपका file, whether it is a CSV or a TSV or Excel file, it supports. Okay, suppose you have a CSV file, so you can directly use CSV file import. Suppose you have no file for data analysis, then Orange directly provide you dataset widget that contains popular data sets from UCI data repository. You simply double click and it will show you the list of data sets available for analysis. Okay, आपके पास data set नहीं है, तो you can directly download the data set from by using the data set widget, and we can directly use it. Okay, for example, suppose we will use Irish data set. So you just type the name of the data set and double click. It will download from internet. Okay, and the green flag showing that is the data set already downloaded. And now you simply connect the data set to a data table to preview the information. Okay, see how simple it is. So by using Orange, you simply interact with the components. Okay, that components are known as widgets. No need, there is no prerequisite of any programming language. No knowledge is required. You simply know the AI/ML phases. Means कैसे हम इसको data means one by one कि पहले data pre-processing करना है. After that we will go for modeling. After that we will go for validation. तो ये प्रोसेस जस्ट आपको पता होना चाहिए, बट देयर इज नो कोडिंग knowledge is required for this. Okay, if you know, then it is better. Okay, so now I will tell you how to connect it. तो एक widget से दूसरा widget हम कैसे connect करेंगे? So for that there is a rule that you just focus on the right and left part of the object. The right part में you can see there is a dashed line. Okay, so that means it only provide output but not accept any input. Okay, in case of file widget you can also see same thing, it provide output but there is no option for input. But what about the table? If you select data table, you just check both it accept input as well as it provide output. Okay, so that means by just watching the objects you can say whether the object takes input or not, or it provides output or not, like this. Okay, so in our just first demo I just show you. If first you will download a data set, for example you simply double click here and type a data set name, or double click by checking the list, you can double click as per your requirement. Okay, and for me, for demonstration, I just use iris dataset because it contains a small amount of records, only 150 number of records. So how to preview it? Now you simply drag the mouse and drop on the data table. काम आपका हो गया. Now you can see the information present in the dataset. Okay, so and you just refer the information part. I just magnify. You just check. There are 150 instances, no missing data is available, 4 features, target with 3 values, no meta attributes. That means you just get a overview of the data set, that is 150 records इसमें है with 4 features. That means 4 columns. You just refer this. There are 4 columns: sepal width, sepal length, petal length, and petal width. And what about the class, target class? Now target with 3 values. Target class is the iris, and iris contains 3 values: iris setosa, iris virginica, and iris versicolor. Okay, so how to visually demonstrate the data set? Let me show you. जो भी ग्राफ आपको बनाना, you can easily draw the graph using this. If you select the distribution, you can see iris. This is a balanced data set, and ये जो तीनों क्लास है all are containing 50 records each, and total 150 records in total. Okay, and what about sepal length, sepal width, sepal petal length, and petal width? So as per your requirement, you can visualize the distribution of the data. Okay, another way is you just connect the data table with feature statistics. Another widget is available, that is feature statistics, to check the statistical features of the data set. यहाँ पे आपको पूरा पता चल जाएगा कि इसमें जो डाटा में डिस्ट्रीब्यूशन क्या है, and what about the mean, mode, median, dispersion, and whether it contains missing information or not, everything you can visualize. Okay, so by using this tool you can easily import your data set, and you can set कि आपका फीचर क्या है, आपका टारगेट क्या है. यू हैव टू सेट. ऐसा नहीं कि इसमें आ जा रहा है तो आपका डाटा सेट में आ जाएगा. नो, in your data set also you can check what are the features for input, or you can say that what are the independent variables and what is the dependent variables. Independent variables are known as x and dependent variable is known as y. Okay, so first we divide the data into 2 parts, x and y. What is x? Now x is the set of features and y is the target class, and x is known as independent and y is depend over x. Okay, तो जैसे डिवाइड हो गया आपका, After that, you divide the data into again two parts. How to divide? Now, one is for training and second is for testing. So training testing में कैसे divide करेंगे? Whether you go for different sampling techniques, or you can split the data into 80:20 ratio or 70:30 ratio. मैं just आपको ये कर रहा हूँ. हम लोग धीरे धीरे आगे बढ़ेंगे. But if you have any doubt, please feel free to ask. तो ये टूल के बारे में हो, क्या क्या कर सकते हैं, क्या क्या नहीं कर सकते, we will discuss everything. If you ask me, I will reply you as per your question. Okay, any doubt regarding this tool you can ask. कि इसमें इसका क्या क्या कैपेबिलिटी है एंड लिमिटेशन भी क्या है एंड हाउ टू ओवरकम दैट लिमिटेशन वी विल आल्सो डिस्कस. ओके, if someone tell you कि is it supports high dimensional data, suppose आपका डाटा हाई वॉल्यूम है, हाई वॉल्यूम ऑफ इंफॉर्मेशन यू हैव एंड ऑरेंज विल सपोर्ट, द आंसर इज यस. आप इसको, बट ऑफिशियली इफ यू आस्क मी द आंसर इज नो. ओके, इन केस ऑफ आप ऑफिशियल डाटा से उसका ये करेंगे, एक्सेस करेंगे, तो दे हैव मेंशन फॉर लार्ज डाटा सेट you should not use orange. Okay, but if we integrate orange with Spark, Apache Spark, then we will extend its capability for large scale analysis. Okay, data analysis. So शायद आपका कितना भी बड़ा होगा डाटा सेट, you can process the data set using Apache Spark and you retrieve the information from Spark to orange and use it or visualize it using the orange canvas. Okay. तो ऑरेंज में जैसे मैंने आपको बताया कि द डैशबोर्ड इज डिवाइडेड इन टू पार्ट. वन इज द सेट ऑफ फीचर्स, सेट ऑफ विडजेट्स, एंड द राइट पार्ट इज नोन एज योर वर्क स्पेस. यहाँ पे हम काम करेंगे, इट इज ऑल्सो नोन एज कैनवास. तो दिस वर्क स्पेस वी डिजाइन आवर वर्क फ्लो एंड दिस इज आवर वर्क फ्लो. जो भी हम डिजाइन कर रहे हैं दैट इज नोन एज द वर्क. ओके, एंड इट इज वेरी इंटरेक्टिव. आप इसमें कुछ भी कर सकते हैं, जो भी आपको डाटा माइनिंग का कुछ कोई भी कॉन्सेप्ट यू कैन डिजाइन यूजिंग दिस टूल. ओके, नाउ कम टू एज पर आवर presentation. First we will discuss about the examine data set. As I told you, for examine data or for descriptive analysis, we use this feature statistics widget that tells us the statistical information about the data set. Okay, now we will try to handle the missing value. In this data set there are no missing values. Okay, suppose आपके पास कोई data set है, उसमें missing value है, so how to process the missing values? So for that reason I will take help of a file widget, और एक data set हम लेंगे जिसमें missing information हो. Okay, I will use a file widget and double click here and browse. Just let me select my data set. And my data set name is simple data. Okay, you can see, you can also import your data set like this. Okay, आपका भी जो data set है, you just import your data set as I use with file widget. Same thing you can use and import with your own data set. Okay, now you focus these columns. In this data set there are 4 columns. Okay, one is Y and remaining are X1, X2 and X3. You just focus, as I told you, the data set should be divided into 2 parts, X and Y. तो इसमें तो नाम में तो X and Y है, but you just check the role में नहीं है, क्योंकि X is the set of features and Y is the target. So here you set the target. You just click here and you set the Y as target. This is important. Okay, कोई भी data set हो, you have to set your target variable. क्योंकि our prime objective is we divided our data into 2 parts, X and Y, and where X is the set of features and Y is the target. So here automatically the file widget is not able to, means sometimes, it is not always, sometimes in some data set, if it is not able to automatically assign the role or select the target variable, then you have to manually do that. Okay. Now click on apply. Now you connect the file with a data table to preview the information. Now information is coming, but you focus on the information provided here. It is mentioned that there are 2.2% missing data is available. That means ये जो data set है इसमें 2.2% information are not present. So this is the case for all the real life where you face this type of problems. Most of the data set contains missing information. Okay. So you have to tackle the missing value input by using some missing value imputation. You can impute the values. Okay. So how to handle that? Let me show you. So for that, there is a widget name. आपको just widget का नाम याद रखना है और कुछ नहीं. And you connect the widget with the previous and the means past and previous and next को select करना. That is your task. Okay. Current में क्या है? What about the previous and what about the next widget? So in this example, our objective is to impute the missing information. Okay. So I use the input widget. Then what about the output? Now output again a data table, and you may rename your data table as data without missing value. Okay. So this is data. This is the original data set. Okay. And this is the imputed value. You just check it. Now it is showing that 2% missing information is present. Okay. So you double click here and check. There are some options. Let me magnify. You have to exercise the option. Okay. Otherwise, it will not impute. So by default, it select as don't impute, means as it is. जो original है वही आ जाए. But most of the time we use this technique, average or most frequent. Some other approaches are also available like model based imputer. This is also one of the powerful technique, but most of the persons use this. Okay, it's a standard practice. You first use average or most frequent, and if you not get the desired output, आपका accuracy ठीक ठाक नहीं आ रहा है, then you may go for model based imputer. Okay. और क्या है? Now another powerful option is remove instances with unknown values. Okay, unknown values क्या होता है कि due to some device failure और जो रीडर जो भी डाटा एक्वायर्ड कर रहा है उसमें सपोज कुछ इशू हुआ तो इट सेट द वैल्यू एज NaN, नॉट ए नंबर. ओके. और सम गार्बेज वैल्यू लाइक -0.999. हमारा ऑयल इंडस्ट्री में वी आर ड्रिलिंग वेल्स, तो तेल हाइड्रोकार्बन के लिए जैसे ही हम ड्रिलिंग करते हैं तो देर आर डिफरेंट लॉगिंग डिवाइसेस आर ऑल्सो अलॉन्ग विद द ड्रिलिंग डिवाइस. सो वो लाइक गामा रे, रेजिस्टिविटी, I just forget the devices. So one is gamma ray, second is आपका रेजिस्टिविटी. ये सब चेक करते हैं कि कहाँ कहाँ पे आपका स्टोन है, कहाँ पे स्टोन है तो कौन स्टोन और रॉक बोलते हैं. तो व्हाट इज द फेसिस ऑफ द रॉक्स, दैट डिटरमाइन द डिफरेंट टाइप्स ऑफ रॉक्स. ये सब ऑटोमेटिकली गामा रे रेजिस्टिविटी से वो दे आर ट्राइंग टू एनालाइज. ओके. सो while capturing the information, if the device has some issues, so it set the value as 999 -0.999. So you should know this is not a value, this is a what? Due to the issue faced by the machine, it set a random value, and that value is minus 0.999. Or in some cases it is NaN. Okay, so you should remove that instances. Okay, that is case 1. Case 2, suppose we have limited number of data, आपके पास sample size ही कम है, तो आप remove नहीं कर सकते हैं. So at that case we will use the average or most frequent approach for data imputation. Okay, and the beauty of the tool is you can set a particular technique to a particular color. आप x1 को एक अप्रोच अप्लाई कर सकते हैं, x2 को सेकंड, x3 को थर्ड एंड y को another approach as per your requirement. Suppose we will apply x1 as average, x2 as model based imputer, x3 suppose random values, and y that is class level, so it's not. Okay, so accordingly you can set. Okay, any doubt please ask. So in this way you apply the data imputation approaches and then you check in our output there is no missing information. Okay, earlier it was 2.2%, now there is no missing value. इसको आप visually भी देख सकते हैं. You can visualize the missing information using the line chart. line chart आ नहीं रहा है. Okay, line, हाँ, I just forget to say another option. In the widget collection, by default, 6 collections are coming. Okay, it's by default. But if you require more, okay, आपको और भी चाहिए means suppose we will go for image analysis. Okay, then we have to install the add-on. Suppose we will go for explainable AI. That means you should tick explain. Okay, or time series analysis. Okay, we will just install these two, time series and image analysis. Okay, so it will take 2 to 3 minutes, and within that period it will install. And I will just show you कि और क्या हमें करना है. Okay, so first we will input the missing values, and then we will discuss how to detect and remove the duplicate records. You can ask me, is it required to detect and remove the duplicate records? The answer is yes. And when it is required, आपको suppose कोई पूछेगा कि ये जो डुप्लीकेट रिकॉर्ड होता है इसको हम ट्रेनिंग में यूज करेंगे या टेस्टिंग में यूज करेंगे. ओके, वेदर वी विल यूज इट ड्यूरिंग द ट्रेनिंग और टेस्टिंग, या इज इट मैंडेटरी टू हैंडल द डुप्लीकेट रिकॉर्ड्स ड्यूरिंग ट्रेनिंग, और इट इज मैंडेटरी और नॉट, और ऑप्शनल. तो ये जो क्वेश्चन का आंसर आप बोल सकते हैं कि हाँ ये हो गया शायद. लेट मी रिस्टार्ट ऑरेंज. So duplicate, to handle the duplicate record, it is mandatory during the training data, but it is not mandatory for the testing data. Okay, आप पूछेंगे क्यों? टेस्टिंग में it is not required. It only takes more time for prediction, but it doesn't make any impact for the prediction or for the output. देखिए ये I just use image analysis and time series. Now it is coming in the collection, widget collection part. And let me just design the workflow again. I will connect the data table, then data table to imputer, and then model data table. Okay, so how to visualize the missing information using line chart? Now this is the line chart, and now you can see, you select data to time series and check. Add plot for x1, x2, x3, and you just add another plot for y. Okay, see, now you focus about x1. So in case of x1, you can check there is a missing, means the curve is continuous up to 33, and from 33 to 36 there is missing. So that missing part means, that means you can conclude that some information are missing or missed in case of X1. And what about X2? In case of X2 also, that is 39 to 42, some information are missing. Okay, what about X3? There is no information missing in X3 and Y. So here we will focus on the X1 and X2. Okay. Now, already we have imputed. So let us check कि ये हमारा हुआ है या नहीं हुआ है ठीक से. You can check. And the connection type is data to time series. That is the most important part. आपको इसको याद रखेंगे. And आप सपोज आज प्रैक्टिस नहीं करेंगे तो कल भूल जाएंगे. Okay. I request you all, you work along with me, and tonight you also practice data to time series. Then you just check, you plot 4 plots, X1, X2, X3 and Y. तो ज़्यादा हो गया. I will use X1, second is X2, third is X3 and fourth is Y. Okay, so now we check the missing curve is now continuous. Okay, similarly in case of X2 also, some information missing from 39 to 42, but now they are imputed. Okay, and there is no missing information in case of X3 and Y. So in this way, you can visualize whether the information are imputed properly or not. And due to Orange is interactive, you can also check like this. Suppose you check. First, I will exercise the option don't impute. Okay, I will exercise the option don't impute. तो जैसे ही हम don't impute प्रेस कर रहे हैं and you check X1, X2, X3 and but it imputed. Why? Because here we manually select here. So we will use don't impute. So if you click don't impute, you just check. There is a gap here. Okay, in case of X1. And what about X2? X2 also, I click don't impute. If you click don't impute, so again, there is a gap. Okay, I visualize both plots. You just check. X1, here it is some information missing, and here also some information is missing. So graphically also, you can check whether your data set contains some missing information or not. Okay. Now come to the second part, how to detect the duplicate records. Okay. If you aware about the inclusion data sets, there is one data set, Credit of 99 data set. Okay. This is a very old data set, but it's a benchmark and a very popular data set in the field of cyber security. So ये जो data set है, in this data set, there are different versions of the data set. So let me discuss about this data set. Corrected. So ये data set जो है, इसको आप download कीजिए. And there are 3 lakh, more than 3 lakh records are there in this data set. But if you apply, I think I have this I have already downloaded. Let me check. Why I will showing this example. I just browse. Yeah, already downloaded. So this is the corrected version of the dataset. Just let me show you. In this dataset, there are 42 features are present, and out of 42, 41 are the X, belong to X, and 1 is your Y. That's the last feature. Let me show you. This is the last feature, and this is your target. You set the target, and the remaining are the feature. You apply, and then connect the data with a data table. यहाँ पे जस्ट मैं आपको मैग्नीफाई करना चाहूंगा. You just check. There are 3,11,028 records are present, 41 features that are the X, and one target feature with 38 values. Means there are 38 classes of the target variable. Okay, Y. ठीक है. But you focus on the input. 3,11,000 आप लेके आपका लैपटॉप में इसको प्रोसेस करेंगे, इट टेक्स मोर टाइम. नाउ इट इज वी हैव पावरफुल प्रोसेसर्स, वी हैव 32 GB रैम, we have GPUs. So now it is possible. But I think in my research time, like 2012, I have received a system with 4 GB of RAM with i7 processor. So whenever I try to simulate this data set, each time I failed. But when I just check the duplicate record, means whether the data contain any duplicate record or not, at that time I use a string matching approach at that time, and it requires more time. But see how orange within a second, how within a 2 to 3 seconds, how orange remove the duplicate records. You just check. Okay. So in the original data set, 3,11,000 records are there, and I will use the unique widget, and this is my unique data set. Unique data points. Okay. Now you check. See, input is, I just magnify. See, then I just now I will magnify. You just check. This is the output, and this is the input. Input is 3,11,028 instances, and whatever the output, only 77,291 records. तो जस्ट इमेजिन, आप वो डाटा सेट का डिस्क्रिप्शन में पढ़ेंगे ना, वहां पे दिया है कि इट इज द करेक्टेड वर्जन ऑफ द डाटा सेट, एंड इट इज द you can use this data set as the training sample. But if the training sample contains this, means the degree of duplicateness is so high, and if you use the 3,11,000 records in your model, each time you will get hardly 80 to 82%, hardly. Okay, because either your model go for overfit or underfit, means you will not able to maintain the bias variance trade-off. Okay, which is the crucial part of your AI/ML modeling. We always maintain the bias variance trade-off. Okay, तो जितना हम मेंटेन कर पाएंगे वो ट्रेड ऑफ को, आपका एक्यूरेसी उतना अच्छा है. ओके, इफ वेरिएंस हाई, देयर इज एन इशू. इफ वेरिएंस लो, देयर इज एन अनदर इशू. सो वो इशू क्या है ना, ओवरफिटिंग एंड अंडरफिटिंग. So many theoretical concepts are there. So to tackle that, you simply give more time to process the information or cleaning your data. That will definitely give you a better result. Okay. So as I told you, in this data set, the input is 3,11,000 and output is only 77,000. Okay. That means only 77,291 records are unique samples are present in the data set with 38 values. Okay. तो इसको लेके आप फर्दर एनालिसिस करेंगे. फर्दर मीन्स द नेक्स्ट इज टू यूज आउटलायर एनालिसिस. ओके, हम चेक करेंगे कि आउट ऑफ दी 77,000 इधर एनी आउटलायर्स आर प्रेजेंट. ई प्रेजेंट, कैसे उसको देखेंगे. सो फर्स्ट वी विल यूज ए स्मॉल डाटा सेट टू चेक द आउटलायर, and after that we will use this data set. Just let me show you with using a small data set. Okay, so outlier क्या है? So outlier, sometimes it is known as the data points are very far from the actual data points, blah blah blah. But outliers sometimes are very helpful in our domain, in cyber security domain. Outliers are the attacks. Okay, क्योंकि कोई भी नेटवर्क के ऊपर फ्रीक्वेंट अटैक कभी भी नहीं होता है. ओके, सो वी विल गिव मोर एम्फासाइज टू ए ऑब्नॉर्मल बिहेवियर. ओके, because we assume that abnormal behavior may be an attack. Okay. So in our field, suppose university में थाउजेंड ऑफ यूजर्स आर देयर, तो आप देखें कि 1000 से 800-900 लोग जो काम कर रहे हैं दैट आर benign, means their behavior is not suspicious, but at a particular point, if one or two behavior are trigger as suspicious, then that are the outliers. Or in cybersecurity, we accept, means we use different models, like different level of model, level 1, level 2, level 3, to handle different type of attacks. Okay, उसको बोलते हैं hybrid IDS. Okay, so in first stage we remove the we detect the exception or outliers, and second, suppose using some unsupervised technique, we cluster the benign and malicious activities, and after that, by using a supervised approach, we labeling them. Okay, which behavior are belong to benign and which behavior belong to malicious. So ये पूरा वर्क होता है. Similarly, in your domain also, you can design accordingly. Any doubt, please ask. And इसको आउटलायर कैसे करना है, just I just check. There is a widget outlier, and you connect the outlier widget, then again connect a data type. Okay, and there are three options: inliers, outliers, and data. You simply connect inliers to data, because we will not use any outliers for further analysis. We simply use the inliers. So in this case, we use inliers to data. Okay, now यहाँ पे हमारा बहुत फास्ट हो रहा है, because I have a high-end laptop, but in your case it takes more time. Okay. Now you just check, out of 77,000 instances, we will eliminate 7,000, approximately 7,000 instances as outlier. आप बोलेंगे, how can you detect? Is there any approach? The approach are, just check. In orange, there are 4 approaches. Okay. The first is one class SVM. Second is covariance estimator. Third is a local outlier factor. And fourth is isolation factor. You can use any of the approach. Let me select the local outlier factor. Okay. In local outlier factor, you just check. There is a contamination parameter there. Contamination. What is contamination parameter? Now, it's a standard practice that maximum we can say 10% comes under outlier category. Maximum 10 to 12, not beyond that. So if you just, I will take a small data set so you can easily know. ये लार्ज डाटा सेट है, इसमें टाइम लगेगा, इसलिए जस्ट मैं इसमें आपको दिखा रहा हूँ. आउटलायर, तो पहले हम विजुअली देखेंगे आउटलायर है या नहीं. तो इसको देखिए, डबल क्लिक कीजिए. These are the outliers. See, if there is a sudden spike, ये x1 and x2 को you just check. You just check the curve. The curve is sudden rise here. If this type of behavior is you see, you can trigger them as a outlier. Similarly, in case of x2 also, there is a sudden spike. Okay, that means your data should not be abnormally, or there is a no sudden rise in the value or spike in the value. If there is some value present, then you should trigger them as outlier. Let me show you how to handle it. First, we will apply average or most frequent approach to filling the missing value, and then now we will check the outlier. Yes, x1 and x2 contain outliers. We will apply outlier detection technique, and then Again, we consider the inliers to data and we will check using the same line chart. Okay. आप अभी देख सकते हैं आफ्टर रिमूवल द आउटलायर्स यू चेक. ओके, एज आई टोल्ड यू हम लाइव देखना चाहते हैं कि हाउ कंटामिनेशन अफेक्ट द आउटलायर, मींस इम्पैक्ट ऑन आउटलायर कॉर. यू जस्ट चेक. If I set contamination to 0 or 1, it is equal to the original call. I will gradually increase the contamination from 1 to 2, 3. When it is 3, there is no change. The outlier still exists. When it is 6, still exists. But when it is 8%, now there is no sign of outlier. आप पूछ सकते हैं कि यहाँ पे भी तो सडन राइज हुआ है. दिस इज नॉट सडन राइज. आपका ऐसा मिल रहा है, जिगजैग आ रहा है, तो इट इज नॉट आउटलायर. दिस इज द नॉर्मल डाटा. ओके. एंड सपोज इन सम अप्रोचेस even if you set 10 or 12% contamination, you are not able to remove the outliers. At that time, you simply skip the data set. Means ऐसे आप नहीं कर सकते. आप 20% या 30% आउटलायर को करके डाटा को हटा देंगे सैंपल से, तो you will lose your information. Okay, maximum 10%. Beyond that, it is not acceptable. Okay, so here we will set as 10% and check. When it is 10%, so this is our out. Now I close it. I will show with another example during the K-mean clustering approach. अभी मैं नहीं दिखा रहा हूँ. K-mean में आपको दिखा रहा हूँ. So now your data is free from outlier and there is no duplicate records present in the data set. Okay, and there is no missing information present. Okay, you go for feature analysis. कैसे feature analysis करेंगे? Now I just take an example of iris, a small data set. And check. Feature analysis के लिए there is a widget namely rank. To select rank, then it will show you the scoring of different feature selection approach. Orange contains 7 approaches. मैं सातों के सातों check कर लिया. And if you tick the 7 approaches, as per your requirement, you can tick or untick. Okay. You just check. In all the approaches, it shows us the first 3 features, that is petal length, petal width, and sepal length, highly contributed to achieve the out. Means they are the relevant feature to determine the out. And what about sepal width? It is negligible. It means it is contributed very negligible. Means whether you take or not, it doesn't matter. Okay. So आप मुझे पूछ सकते हैं 4 तो attribute है. There are 4 attributes. And out of this 4 attributes, is it required for feature analysis? The answer is no. Feature analysis specially हम use करते हैं if our data size is very high. Okay, like image up the moment I will show you during the image analysis. So in this way, you can apply the feature analysis technique to your data. Okay. Now we will go for save our information. Suppose these are our processed data after completion all the sorry, I forgot to discuss the data standardization approach. So for that means normalize. Okay, whether you normalize your information using min-max normalization or G-score normalization, ये सारे available है यहाँ पे. You simply use pre-process widget and then again connect the pre-process with the data type. इसको double click कीजिए. There is an option normalize features and there are 5 normalization techniques are available. Okay, and the most common is normalize to interval -1 to 1 or 0 to 1. Okay, Suppose you ask me, नहीं मुझे चाहिए -5 to 5 और -10 to 10, but यहाँ पे तो है नहीं. So if you design your own approach using orange, it is also possible. Okay, let me show you. So first we normalize the information and we assume that this is our processed data set. Okay. Similarly, in the credit of 99 also, we select the pre-process and then we will save the data. And in normalize, we will select normalize to interval 0 to 1. Okay. And you can save your information. एक बार process हो गया आपका, then by using the save widget, you can save your processed data set. Corrected, आप सेव कर सकते हैं. Revise data. Suppose I will save into the download folder. Okay. Now the data saved in my download folder. Okay. So the objective of the session is we should apply the different data pre-processing technique and store the processed data. Now we successfully accomplished. हमारा data save हो गया है. Okay. Next we will go for modeling. Okay. So how to model? Again I use a file widget and उसके बाद ये सब का जरूरत नहीं है. You simply delete them. You use a file widget, double click. Now you import our processed data set. Yeah, corrected, revised data. Okay. And you set the target already set. Okay, it's okay. क्योंकि हमने पहले already कर चुके हैं इसीलिए automatically ये आ गया. Now, as I told you, we divide the data into X, initially X and Y, and after that we divide the data into two parts, training and testing. So how to split our data? Using the data sampler. This is important. Just write down the. Please, any doubt? See, you just divide the data into two parts by using the data sampler. Okay.
Sir? Hello? Hello? Hello?
Sir, am I audible, sir?
Sir, there is any pre-processing techniques available, sir, in this software? Pre-processing or...
Sir, can you please repeat your question, sir?
Pre-processing data analyzing or false data removing.
Sorry, I'm not heard you, sir. Pre-processing dot.
Sir is asking about can we perform data cleaning operations, pre-processing things using
Yeah.
orange tool?
Yes,
Yes,
sir.
sir. Yes, sir. Yes.
Especially this tool is supports a lot of pre-processing tasks like data cleaning. In data cleaning, missing value imputation, your duplicate record handling, outlier analysis, feature reduction. Every data mining, the techniques present in the data mining phases, all are present here, sir. All are present. And to know the widget detail, you simply visit their portal and go to the document part, and here there is the option widget collection. Here you can get complete information about the widgets. Okay, and these transform widget and data widget specially used for data cleaning or data pre-processing. Okay, and for visualize your information, these are the widgets. Okay, and for modeling, for supervised modeling, these are the widgets are available like KNN, DCNT, random forest boosting, tagging, stacking. All approaches are present here. And for assessment, model assessment, there
Sir,
is a evaluate.
how can import these tools in that software? How can import?
Sir, like see, you simply all widget collection you can find here, sir. In data same, which are showing there. See, data, and the first widget is file. Same widget is also available in your dashboard. You see, this is the file widget. Okay. Then in transform, you just check the remaining widgets, which are categorized as transform. ये सारे widget आपका यहाँ पे available है. And one by one, you can explore the widgets, like to integrate data from different sources. So there are two ways. What are them? Now, one is merge data, and second is concatenate the data. Okay. इस तरह से आप you just explore the widgets one by one, and you can get more information about it, how to combine data from different sources, how to pre-process the data. Especially pre-process the data, you use impute, second unique, third pre-process, fourth rank. This is the rank. Okay. And to merge the data, we specially use the aggregate columns, group by, so many options are there. Okay. Means you just explore one by one as per your requirements. Okay. And if you have a ready-made data set, आपको नेट से डाउनलोड करना है तो जरूरत नहीं है, आपको मर्ज डाटा मर्जिंग इज नॉट रिक्वायर्ड. एज लाइक मी कि मैंने डाउनलोड किया, डायरेक्टली आई यूज द डाटा. बट इन सम केसेस इफ योर डाटा कम्स फ्रॉम डिफरेंट सोर्सेस, then you use the widgets accordingly. Okay, sir?
Okay, sir. Thank you, sir. Thank you so much.
Yeah. So here we will discuss how to supervise model. Means suppose you have a supervised problem. So how to address the supervised problem using Orange? Within 3 minutes we will discuss. We will complete this. You just import your data set by using the file widget. Then by using the data sampler, you divide the data into training and testing set. Okay. How to divide? Now you just connect two tables. Okay. And the connection type is, the one is your data sample to data, and second is you just double click remaining data to data. Okay. You just explore one by one, and आप इसमें देख सकते हैं कि how the data is divided. So actually the original data set contains around 77,000. Now they are divided two parts, 49,000 in training part and 21,000 in testing part. तो आप पूछेंगे नहीं, as per my requirement I will split. So you can also check the splitting criteria. आप इसको 70 to 80 कर सकते हैं as per your requirement, or you can say that no, I will use cross validation. It is also available. Suppose you will use bootstrap sampling. It is also available. As per your requirement, you exercise the option. And let me select cross validation or fixed partition. Means I will divide the data into suppose 80% and 20%. Okay. And click on sample data. So now my data divided into two parts. One is this is my testing data, training data, and this is my testing data. तो ऐसे आप डाटा को डिवाइड कर सकते हैं, ट्रेनिंग एंड टेस्टिंग. ओके. नाउ यू कनेक्ट द ट्रेनिंग डाटा इनटू टेस्ट एंड स्कोर. ये थंब रूल है आपका सुपरवाइज के लिए. इसको जैसे मैं ड्रॉ कर रहा हूँ, यू शुड फॉलो द सेम स्टेप. टेस्ट एंड स्कोर से साथ कनेक्ट करना है. देन टेस्ट एंड स्कोर connect with the confusion matrix and ROC. Okay. And here you select the approach. Suppose आप random forest use करेंगे, a learning approach, or you may select KNN. Okay. Almost all learning approaches are present here, popular learning approaches. Okay. If not present, you can also simulate using Python. Okay. Then you connect the trainings data into the learning approaches. Okay. Then in testing part, you connect with a predict widget. Okay. And then connect the trained model to the prediction. आप मुझे पूछ सकते हैं दो मॉडल क्यों कर रहे हैं. आप जितना भी मॉडल यूज करेंगे सबका आउटपुट अलग अलग आएगा. ओके. इफ यू कंबाइन देन गो फॉर ensemble approach. That is also possible using Orange. Now we connect the prediction widget to confusion matrix and ROC. So this is the complete cycle. This is the complete cycle of your supervised model. Okay. See, so you pick test and scale. Now you can check your accuracy. हमारा accuracy कितना आ रहा है ना? By using random forest we achieve 99.5% accuracy. Wow, great. And by using KNN our accuracy is 99.1%. See, without optimization technique we achieve a better classification accuracy, that is more than 99% during training phase. Okay, now come to the testing part. You see, in testing part also the classification accuracy is 99.5% using random forest and 99.1% in case of KNN. You can also add more approaches as per your requirement. Simply right click, select a approach like suppose decision tree, and then connect the tree here, connect the data to tree and connect to the prediction. Okay, there is some issue. Tree failed with error, to warning. What are the warning? Binary does not handle attributes with more than 16 values. Okay, decision tree does not support 16 values because in this data set there are 38 classes. So decision tree supports only 16 classes. Okay, beyond that it is not support. Okay, so we'll remove it. So in this way you can design or simulate your supervised approaches using orange, whatever your data set is, and you can also check the result using the confusion matrix and ROC. See, this is the confusion matrix. Okay, because this data set contains around 38 classes, so the confusion matrix is very large. Let me show you with a small data set, so you can easily visualize it. Confusion matrix and ROC. Sorry. And here you just select, suppose I will use random forest. Any approach. Connect. Now you check. This is the confusion matrix. Okay. And this is the ROC. ROC for class 0, class 1 and class 2. आपके पास जितना क्लास होगा आपका उतना ROC करेक्ट ड्रॉ होगा. Okay. And what about the confusion matrix? Now as per your number of classes present in the data set, same 3 cross, suppose 3 है तो 3 cross 3 matrix जनरेट करेगा. Like 38 classes है तो 38 cross 38 matrix आपका कंस्ट्रक्ट होगा in case of multi-class classification. Okay. Okay. Now, if you want to know about the confusion matrix, then the best portal is you simply write in Google confusion matrix wiki. If you have any doubt, क्योंकि इसका नाम ही confusion है, so to remove the confusion, you simply visit the site, and it is excellently documented about the confusion matrix. What is confusion matrix? How to determine the true positive, false negative, false positive, and false true negative. Okay, along with the formulas. जो यहाँ पे output आपका आ रहा है, like what is the formula for AUC, CA, F1, precision, recall, MCC, everything is mentioned here. You just check. Everything is mentioned here. Okay, TPR, true positive rate, recall, sensitivity, सारे का formula दिया है. You simply use the formula to get the result. Okay. Now you just take a screenshot of this workflow. This is similar. This is common workflow for supervised approach. Now come to the unsupervised approach. In case of unsupervised approach, let me show you. We will use a cell minute data set. आपको easily समझने के लिए ये होगा. See, I just take a data set, and in this data set, one can easily say that what about the outliers? ये आपका एक outlier है, ये एक outlier है, ये एक outlier है, ये एक outlier है. Okay, एंड ये दोनों हो भी सकता है, नहीं भी हो सकता है. ओके, so in this data set आपको देखने ही means by watching the data points one can easily conclude that some points are outliers. Okay, so इसको चेक कैसे करेंगे? by using k-means. So k-means कैसे हम implement करेंगे using orange? You simply type the k-means widget, it is over. How simple it is, you just check. To implement a supervised approach, you just write the approach and then visualize your result with a scatter plot. Okay, and as per the cluster information, it is showing that there are 3 clusters are formed, named as C1, C2, and C3. Okay, and they are also categorized as per color code. Okay, now you can focus on this part, this point. Actually, it is outlier, but it is as per the result, it belongs to C2. Similarly, these are also 3 outliers belong to C1. So how to refine your result? Okay, and another way is, यहाँ पे जैसे आप डबल क्लिक करेंगे, there is a approach silhouette score. There is that. Okay, that is not available here. Okay, no problem. So why data pre-processing is required? Just I am going to show you. So see, this is the output of k-means clustering technique. Now I will just apply outlier detection technique over the data. Then the output I will connect with k-means, and then the output connect with a scatter plot. Okay, हमने just एक outlier widget को यहाँ पे ऐड किया, बाकी रिमेनिंग सेम है. Now you check the result. This is without removing the outliers, and this is the result with using the outlier. Now you check how the result is refined. Okay, यहाँ पे आपका आ रहा है, ये जो points देखिए, ये these points are showing. Okay, actually it is wrongly showing that it belong to C1, C2, because that are far from the data points, normal data points. Okay, but here you can check. Now it is excellently cluster your information as per your requirement or as per the inherent property of the data points. It categorize your or clustered your information by 3 groups. Okay, so if you process your data and give more time to process the data, then your data definitely achieve a better accuracy during modeling. Okay, any doubt? And what और क्या क्या इसमें कर सकते हैं? Now you can also apply image analysis. जो MATLAB में करते हैं इसको you can also apply image analysis using Orange. And if you give me 5 minutes, I will demonstrate you. For image analysis, you simply import images by browse the image into any data set. Suppose it is a tumor data set or breast cancer data set or any malware image data set. आपके पास जो भी डाटा है और animal classification data set, you can directly use the data set as like me. I just show you. Yeah, we will use the image data set of animal classification. You just check. If you click image viewer, it will show you the image of cat, dog, and lion. Okay, there are 3 classes are there. And how to use it? First step is go for image embedding. And in image embedding, you use the SqueezeNet option because it is locally approach is present. No need for any internet connection. Okay. Then you connect the image embedding to data table. And after that, जो हम supervised technique means our objective is to design a supervised approach. So as I said earlier, same thing. You just use test and score, then confusion matrix, ROC, okay, and approach. I will use neural network, okay, and connect it your data is connected to neural network. Okay. So now it takes just 10 to 15 seconds to embed the information. Okay. And after that, our training process will start. Okay. Similarly, for testing, we will use the test data set. Then same thing, you go for image embedding. And remember one thing, same technique which you have used in the training process, same thing you will use in the testing process. So we will use SqueezeNet. Then we will connect with a data table to prediction. Then again you connect prediction to your confusion matrix and arrows. Okay. And for prediction, you require the information, and now our model is complete. Okay. एक बार सुपरवाइज पढ़ लिया तो बाकी it is common for image, test as well as tabular data. Okay. Now you check. We can also analyze the image using the image where by using the confusion matrix. Accuracy कितना आ रहा है? Accuracy is 95.3%. And if you check the confusion matrix with the image viewer, you can check about your stability of the model. Okay, you just check cat. So these cats are classified as cat. Okay, out of 219 number of cats, 210 number of cats are classified as cat. Okay, 219 से 210 सही से classified हुआ है. And 9 cats are classified as dog. Which are them? See, these are the cats. They are classified as dog. Okay. Similarly, come to the dog part. Out of 202 dogs, 190 dogs are classified as dog, but 12 dogs are classified as cat. You just check the result. Live आप जैसे ही confusion matrix में click कर रहे हैं, that corresponding result is showing here. Okay. So due to that result, it is interactive. Okay. Similarly, out of 28 number of lions, all lions are classified as lion. So this is the testing result. Training result. What about the testing result? Check. So out of 50 number of cat, 44 are classified as cat, 5 are classified as dog, 1 is classified as lion. So you can easily check your result. Okay, you can easily check your result. How many number of cats are classified as dog or lion by using orange. Okay, very easily. Okay, and accordingly you analyze the remaining 2 classes. Okay, that is lion and dog. Similarly, you can also apply text analysis, and in unsupervised approach also so many approaches are there, like TB scan approach, nearest neighbor approach, TSNE approach. What is TSNE? T stochastic neighborhood embedding. This is the approach for dimension reduction. If someone asks you how to visualize a high dimensional data by using a scatter plot, so you can use this TSNE approach to visualize a high dimension. Suppose it's the dimension of 1000 or 5000 or 10,000. You can minimize the dimension from 10,000 to 2 and you can visualize. Okay. For example, in this, it takes more time. It's a small. This is a small data. Let me select iris data set. And I will directly connect to TSNE and display using the scatter plot. This iris dataset contains 4 features. Okay, now you check. So 4 features, but we will use TSNE-X and TSNE-Y. See, the way we reduce from 4 to 2. So जो दो पार्ट में डिवाइड हुआ, that is TSNE-X and TSNE-Y. So in this way, you can visualize your high dimension data with using the scatter plot. Okay, this is a unsupervised approach, T stochastic neighborhood embedding. And another approach is PCA, Principal Component Analysis. Here also you can do using PCA. Same. जैसे आप इसमें किया है, same thing you can use PCA, connect with a scatter plot, and you visualize the result. As per your principal component 1 and principal component 2, you can visualize the data set. Okay. So in this way, you can perform so many tasks, so many AI/ML concepts you can implement visually. Okay. No need to write a single line of code. But if you know Python, then it is better. How? Let me show you. Python. You simply write Python. Okay. This Python widget, you can write code like this. Okay. ऐसे आप code लिखेंगे. So, and you can execute the Python script here. Okay. चाहे if someone asks you कि deep neural network possible है? The answer is no. By default, we cannot use DNN approaches using Orange. But by using this Python script widget, we can implement deep neural network using Orange. Okay. आप इसमें उसको implement करके you can provide the data into the Python script, that is the deep neural network means approach, and then you get the result from the Python widget. Okay. So due to time restriction, and initially I was late for 10 minutes, so sorry for that. And if you have any doubts so far, please ask. Or you can also chat your question. Whatever your doubt, you please ask. Yeah, already sir said the download link. Excellent. Yes, I just just write on my mail ID sahu_santosh@onjs.co.in, and this is my mobile. So if you have any problem, any question? Just write on it.
Sir, hello. Sir,
Sir, please. Any doubt, please ask.
Sir, kindly write your question in chat
sir,
box
hello.
if any
Yes,
problem
sir,
is
please.
there.
Hello.
Yes, sir, please. You are audible, sir. Please. Please go ahead. Please go ahead, sir. Go ahead, sir. Please ask.
Hello.
Yes, sir. You are audible, sir. Please.
Yes, sir. Yes, sir. Before you are showing some mathematical formulas, sir, in website, please can you share me it possible, sir? FNT values for.
Sir, mathematical formula, sir.
You are showing some websites, sir. I'm missing power cutting. That please can you share me mathematical formulas, FNT, PNT values.
Yeah, sir. Sir, I will share with the organizer, sir. You just collect from them,
Oh,
sir. Okay, sir.
okay.
And
Thank you.
later on also, while interact with Orange, if you have any doubt with your own data, you just try it and explore one by one the widgets. If you have any doubt at any point of time, please just send a mail. Within 1 or 2 days, I will reply your mail, sir. Okay, sir.
If possible, please share me videos, sir. I will again
Yeah.
watch your.
Sure, sir. Sure.
Oh, okay, sir. Thank you so much, sir.
And
Thank you.
sir, Orange also provide some documentation, and they have also provide the YouTube tutorials. You can also refer this tutorial by the Orange
Oh,
team, sir. But
Okay, sir. Thank you.
in this tutorial, they discuss only the basic part, like how to scripting, not cover this, how to scripting using Python, or suppose you will go for modeling using deep neural network or big data analysis. That is not covered by them, but you can accomplish it. I have already, I have 2 research paper related to this. And in Orange, we integrate with Apache Spark and simulate the big data analysis with our laptop. Okay, so it is possible.
Sir, I am missing some bits, sir. You are showing some website that mathematical showing, sir. Your if
Okay,
FNR
okay,
values to be.
okay, okay, sir, sir. You go to
Uh, uh,
confusion matrix, sir.
please show me, sir, once again.
It is very
Uh,
essential to know about the confusion matrix. You just in
yes, yes, sir.
Google, you write down the confusion matrix Wikipedia, and
Yes.
you just click the Wikipedia link. This link provide you a lot of information about the confusion matrix, and
Confusion. Yes.
yeah, and if you know the formulas, see, आपको
No.
बुक में इतना elaborately इतना easily mention नहीं है, but this page dedicatedly for confusion matrix, and it covers almost all formulas, okay, all mathematical formulas which we have discussed in our Orange, or we are by using Python also. Scikit-learn package, we visualize or we check our accuracy with some other performance matrices, and without knowing the formulas, actually formulas, okay, how to obtain that performance matrices, this is the formulas, okay. And
Okay.
to achieve this, you require only 4 parameters, that is the true positive, false negative, false positive, and true negative. You can also simulate using Excel. आप एक्सेल में ये 4 इनपुट देके बाकी सारे फॉर्मूला यू कैन सिमुलेट, ओके, बाय
Okay.
सिंपली रेफरिंग दिस पोर्टल.
Okay. Okay. Okay, sir. Thank you so much, sir. Thank you.
Welcome, sir.
Thanks.
Any more question, please ask.
So there are few questions are asked in the chat box, sir.
Yeah, yeah.
Virabhadra sir, he has asked how to handle different data types, numeric, categorical, text in Orange, sir.
Okay, okay. Here you can see. Let me show you. Here, automatically, see, sir, this iris data contains how easy it is. Just I am showing. In iris data set, if you see the values, let me show you. The values are 0, 1, 2. Okay, the values are 0, 1, 2, and it is a numeric value. If you want to convert them categorical, then it is very easy. You simply here set as categorical, or you can set as numeric. As per your requirement, you select here, click on apply, it will work. Okay, no need to go for any coding or sophisticated approaches for encoding them. And similarly, another is one hot encoding. ये भी you often use it. That I think it is in data pre-process part. See, in this data pre-process, continue discrete variable and discrete to continue variable. These 2 options are used to convert continuous variable to discrete, and discrete variable to continuous variable. Okay, by using the or individual, I think there is also another option, discrete. Yeah, these widgets are also helpful for convert your continuous data type to discrete data type, and another is continuous. See, this is used to convert discrete to continuous. Okay, so in the like one hot encoding, this is very much essential for convert your numeric data to categorical data. Okay, जैसे आपका मेल फीमेल है, you convert to 0 and 1 by using one hot encoding. You can do that. As like my cyber security data set, it contains 38 number of features. तो आप इसको एज ए स्ट्रिंग लेंगे तो इशू होगा. सो यू जस्ट अप्लाई दिस वन हॉट एनकोडिंग टू apply a constant to that data. Okay, ये इसका application just मैं Excel sheet में आपको बता देता हूँ how it is very helpful. I will go to see sir, just here in our data set, this is the class level. Okay, and this class level contains 38 classes. Okay, so if you take normal or any attack type, then some models will not work. Okay, so to apply a constant to that string value, we use one hot encoding. Okay, जो मैंने आपको दिखाया था. Similarly, यहाँ पे देखिए, it is a protocol field. There are 3 protocol mentioned in the data set. One is UDP, TCP and ICMP. तो ये तीनों को हम क्या करेंगे? We will assign 0 to TCP, 1 to UDP and 2 to ICMP. In the similar fashion, you can assign a constant to a particular feature. And आप इसको apply नहीं करेंगे तो during the modeling, it will skip by the model. Model में क्या होता है? The moment you give a non-numeric value, it will not accept. Okay, it accept only categorical and numeric. So ऐसे string type जैसे ही आपका आएगा, it will not accept. So for that, you have to assign a constant to that particular string value. So for that, we use specially 2 widgets. One is discretize and second is continue. Okay, and जैसे आपका मोड मीडियन निकालने के लिए आपका होता है ना 10 to step wise आपका वैल्यू होता है 10 to 30, 30 to 50. That step wise value you can continue into continuous format or continue to discrete type using these 2 widgets. Okay, and believe me, all kind of statistical approaches are covered by Orange. Okay, initially it was not covered, but nowadays it is very much matured, and you can apply any statistical approaches, any modeling using Orange. Okay, all the popular approaches are available here, and for sophisticated approach, you have to implement in Python. Okay, next question. I have covered this. What about the link? Yeah, this is the link. Means by refer the link, you can study different features by the creator of the tool. And here they have covered partially, not fully, partially, almost means some widgets they have covered. But I request you all, you have to visit their portal. Actually, how to learn these two. हमने भी ट्रेनिंग कहीं से नहीं लिया. It's a self learning. First, I visit the portal and explore the different tools. Like nowadays, we are working with XI techniques. Okay, so you go to document, just widget catalog. क्या नया widget आ रहा है? You have to study it. Okay, so if you scroll down, there is a widget explainable AI. Okay, for explainable AI, there are 5 widgets are available. Okay, so you have to know how to use them. तो आपको कैसे पता चलेगा? You simply click it. Okay, and you focus on the workflow diagram. Theory भूल जाइए. First you focus on the workflow diagram. Okay, so we know XI techniques is used to interpret a model. Okay, जो trained model होता है या learned model होता है, that model we have to interact with that model by using some approaches like SAP and LIME. So many approaches are there. Popular approaches are SAP and LIME. Okay, so how to design it? You simply see file. Okay, that means I import a data set. Then I use a learning approach, that is logistic regression. But it is not limited to logistic regression. You can apply any learning approach like support vector machine, decision tree, random forest, any approach. Then you connect them with feature importance. So you just focus on the input of the feature importance. It requires 2 input. One is a model and second is a data set. Okay, or training set. And the output is a data table. And that data table show you the feature importance. You just check. So जो हम feature ranking में कर रहे थे, that can be also used. Means we can calculate the relevant features by using the XI technique, explainable AI techniques. Okay. And if you know more about the examples, how it is working, what are the inputs, what are the output, you can refer. But जैसे काम करते करते हमें एक एक्सपीरियंस हो जाता है, and after that you simply refer the workflow diagram. Okay, that is enough. वर्कफ्लो डायग्राम जैसे आपका नजर आ जाता है, पूरा टोटल हिस्ट्री आपको पता चल जाता है. लाइक एक्सप्लेन मॉडल, एक्सप्लेन प्रेडिक्शन, तो यू सिंपली क्लिक एंड फोकस ऑन द वर्कफ्लो डायग्राम कि ये कैसे काम करता है. ओके, एंड अकॉर्डिंगली यू जस्ट रेफर द थियोरिटिकल पार्ट कि क्या होता है एक्सआई टेक्निक, हाउ टू इंटरप्रेट अ मॉडल, व्हाट आर द स्टेप्स, एंड देन यू डायरेक्टली यूज द एक्सप्लेन प्रेडिक्शंस. ओके, so accordingly you study one feature, means if you practice daily, then within 15 days you master in Orange. Okay, no previous, no coding, nothing is required, no previous knowledge is required, and you apply reverse engineering technique here. कोई भी approach को, like if you study a research paper and you try to simulate the existing work, within 10 minutes you can simulate. Any more question, please ask. Yeah, difference between Python and Orange. Actually, Orange is implemented using Python. So Python is the programming language that is used to develop Orange. Due to that reason, Orange is fully compatible with Python. Okay, so Orange Python में develop हुआ है, इसीलिए Python script directly यहाँ पे काम कर रहा है. And you can also install packages using Orange. आप जो Python में जैसे आप पैकेज इंस्टॉल करते हैं, pip install package name, in a similar way you can install package in Orange. And same आपका जो भी आपका जैसे ये कोड लिखा गया है, like import numpy as np from Orange data, and you can simply run and the script is running. Okay, and vary the output. You connect the Python script with a data table, then you will get the output. You see, this is the output. Okay, this is the script, and this is the output. So you can execute any Orange script. Yeah. So ये आपका कोड है, ये आपका आउटपुट है. Okay, and you can also provide input to that Python script, and you develop your logic, and you can export your result to Orange workflow. Okay, so Orange is implemented in Python and it is fully compatible with Python. Any more question? You just visit the portal, sir, Orange portal, and they have well documented all the widgets. Okay, and you can explore one by one. Go to document and widget collection. Here you can get more and more information about a particular widgets. I have not prepared any video for this. Actually, less amount of video tutorials are available using Orange. Okay, in future I will try to upload, sir. Sure. And later on also you have any doubt, you may contact, this is my email ID and mobile number. You may contact, and we will try to address your issues collaboratively.
Dear audience, anybody have any doubts?
Okay, so it's a really excellent tool, and you please use this tool. And it's a visual programming tool, so no need to learn a programming language, and only Python is required to extend the capabilities of Orange. Okay, otherwise Python is not required. Okay, and you can use this tool for image processing, text analysis, your network analysis, graph analysis, and explainable AI. It covers almost all type of AI/ML modeling, but large language development of generative AI is not covered. Okay, large language model this is not covered. This is separate field, but remaining part AI/ML part is covered. Okay. So thank you so much for your attention, and I really thanks to Madam and
Yeah, thank you so much, sir.
Sir,
welcome.
thank you so much, sir. A very good evening to all. On behalf of the Department of CSE, Cybersecurity, AI&DS, and VNR-VJIET, I extend my sincere gratitude to our esteemed expert, Professor Santosh Kumar Sahu, sir, from ONGC Dehradun, for delivering today's insightful session on agentic AI frameworks and tool chains. Sir, with your 14 years of rich experience, you gave us a clear and detailed explanation of the Orange data mining tool, showcasing how it can be effectively used for data analysis, visualization, and model building. Your practical demonstration made the session highly encouraging and has provided our participants with hands-on knowledge that will surely benefit their learning and research. I also thank all the participants for your active involvement and enthusiasm throughout the session. Your curiosity and interaction made this session even more meaningful. Thank you, sir. Thank you so much, sir.
Okay, ma'am. Welcome, ma'am. And good night to all of
Good
you.
night, sir. Thank you so much, sir.
Thank you, sir.
Sir, Sandeep Singh, sir. Sandeep Sengar, sir. Good evening, sir. Very good evening, sir.
Good evening, madam. Can you hear me?
Yes, sir. We are hearing, sir. It's clear. Sir, we just to tell some introduction about you, then you can start the session, sir.
Definitely. Thank you.
So, very good evening to everyone. We are truly honored to welcome our today's speaker for the second session, Dr. Sandeep Singh Sengar, sir, to our ATAL FDP program. Dr. Sandeep Singh Sengar is a senior lecturer at Cardiff Metropolitan University, United Kingdom. He also serves as the cluster leader for computer vision, image processing, and represents the British Computer Society. Prior to his current role, Dr. Sengar was a postdoctoral research fellow in the machine learning section of the computer science department at the University of Copenhagen, Denmark. In 2022, he was a visiting researcher at University College Dublin in Ireland. Dr. Sengar earned his PhD in computer vision from IIT Dhanbad and his MTech from Motilal Nehru National Institute of Technology, Allahabad, India. He is a fellow of the UK Higher Education Academy and a senior member of IEEE. His research focus on machine and deep learning, computer vision, and image and video processing. Dr. Sengar has an extensive publication record in leading international journals and conferences. He has published in top tier venues such as IJCAI, BMVC, EMBC, CVIP, MIE, and EFMI. He is a member of the editorial boards for Signal, Image, and Video Processing and the International Journal of Imaging Systems and Technology. He also serves on the Board of Studies at Universal AI University in Mumbai, India, as an external examiner at the London School of Innovation and reviews research grant proposals for EPSRC UK, NMRC Singapore, and Cardiff Met. Additionally, Dr. Sengar is a PhD examiner for several prestigious institutions, including the University of South Wales, Cardiff University, and the Indian Institutes of Technology and the National Institutes of Technology in India. He has played key roles in international conferences, such as serving as an organizing chair and distinguished guest. He has delivered expert talks worldwide at prestigious institutions, including Trinity College Dublin, University College Dublin, Technical University of Denmark, Cardiff University, multiple Indian institutes of technology, including IIT Kharagpur, IIT Roorkee, and several others. So, thank you for joining in our today's FDP program, sir. Over to you, sir.
Thank you, madam, for this introduction. So let me share my screen. I hope you can see my slide. Please confirm.
Yes, sir.
Yes, sir.
Okay, so thank you everyone and organizing committee members and management for inviting me in this talk. So today I'm going to talk about deep learning and its application in medical image segmentation. So in this talk, first I will give I will start with the introduction of deep learning, and then like we will discuss a few application areas related to medical imaging, few publications or other things related to medical imaging. And so all these things are related to computer vision. So like we will move a little bit, we will touch about the computer vision also, because if we are applying deep learning in medical imaging, then that is the part of computer vision. So let's start the talk with one of the beautiful picture, because we are talking about image data sets. So we should know about the image also. So one beautiful picture with one famous quote. The quote is, "One picture is worth more than thousands of words," right? So all of you know about this quote. Means if I will give you one picture and I will ask you a few questions, or in parallel I will give you 500 or thousands of words and I will ask you questions, then you will prefer a picture to give answer, right? So pictures and all these image and videos, they have very important role in our life. So there is one beautiful picture in front of you, and in this picture we can see many things, right? We can see many things, we can interpret many things from this image data set. We can say this is a data set. Now from this image, what we can interpret, what we can see, like we can see small village is there, hill areas is there, beautiful colors of skies are there, two tractors are there, right? Road is there. So like many things we can see, many things we can interpret from this image data set. So who we are the human being. So we as a human being can see the content from this image data set, then it is called human vision, right? So we are interpreting the contents, we are telling like there are tractors, there are road, hill area and all those things. That is called human vision. So if the same task is done by computer, that means computer is telling you in this image we have two tractors, we have like hill areas or all those things, different colors of skies, then it is called computer vision. So nowadays computer vision is one of the very popular term, and we can say it's a buzzword, and we are using this computer vision in many different domains. Like one of medical imaging is one of the domain in which like we are applying the computer vision techniques. So for solving the computer vision related problems, either in medical domain or many other domains, we are using the deep learning, right? So we should know about all the deep learning things, and we should know about this medical imaging things, computer vision, to understand all these things like properly, like how we can integrate all these environment together, right? So I hope the computer vision definition is clear to everyone. Now for solving the computer vision problem, as I said, we are going to use deep learning techniques. So let's have a quick overview of deep learning first of all. So there's one famous diagram in front of you. All of you might have seen this on internet. So in this diagram on the top, there is artificial intelligence, right? So artificial intelligence means machine mimic the behavior of a human being. Machine mimic the behavior of a human being means machine work like a human being. So there are so many examples like robots, autonomous car, where machine work like a human being. The sub part of artificial intelligence is machine learning. Machine learning means learning from experience, learning from data set. After learning, we build a model, and that model can predict the output for unknown input. So there are so many examples of machine learning. Just one of the famous example is housing price prediction in medical imaging, like cancer prediction, tumor prediction, and like any kinds of disease prediction, right? So we use machine learning for that perspective. Then a sub part of machine learning is deep learning. So if we go a little bit in a deep of that machine learning, that means if you are going to use large number of layers, and we are going to use a large number of parameters for getting higher accuracy, then we apply the deep learning techniques, right? So all are they are not independent, they are dependent on each other. One is the sub part of another one. So now if you're talking for deep learning, then we can say deep learning is the advanced version of artificial neural network, right? ANN. And ANN is inspired from human brain neurons. Like in a brain, we have a neurons. These neurons are connected to each other, and using that connection, they take decision. Likewise, in a deep learning, we have like higher number of layers. These layers are connected to each other, and using this connection, like we take the decision. So I will discuss all these things in a detail, like how we can use this deep learning, how like we can enhance our like model and all those things I'm going to discuss. So if you are applying machine learning, a deep learning algorithm, that means we are trying to find the model. We are building the model. And if we are going to apply deep learning techniques, then we expect like we should have a large data set. If we don't have a large data set, then it is very difficult to get higher accuracy, right? So if you have a large data set, then we can expect we'll get higher performance, right? So these are the like some prerequisite when we apply the deep learning techniques. Now let's understand the difference between machine learning and deep learning. If we are talking for machine learning, that means we are extracting features manually. Manually means like we give input data set, and we as a human being, data scientist or radiologist will extract the features from those image data set, right? After extracting the features, these features will be given as an input to the classification model. And here the classification model may be like any of the like machine learning model. I have shown here like ANN structure of just like a neural network, but it can be anything like a decision tree, random forest, or like other, including ANN. Then after that, we'll get the output, whether it's a car or not car. That's a classification problem. So this is about machine learning, where like we extract the features manually. But we have deep learning, another technique. Deep learning is the end-to-end approach. End-to-end approach means there is no need to extract features manually. Directly we can give input, image, and we can get the output, right? So feature extraction plus classification task is taken care by our model, right? So no need to manually do the things, and like just we need to give raw image as an input, and we can generate the output. So that's the reason this deep learning algorithm is called end-to-end approach, right? So this is a basic difference between machine learning and deep learning. Machine learning is not end-to-end, deep learning is an end-to-end approach. So there are many different architectures are available for deep learning, for example, CNN, convolutional neural network. Mainly we use convolutional neural network for image, video data set. And there are so many applications, there are so many problems like image recognition, object detection, tracking, and all those purposes, like mainly we use CNN. Then next is RNN, recurrent neural network, and mainly we use RNN for NLP task purpose, right? Then LSTM, long short-term memory, gated recurrent unit, same NLP, text recognition, handwriting recognition purpose, gesture recognition purpose, we use this LSTM GRU. Next, we have deep belief network and deep stacking network. So likewise, we have a different network, different types of deep learning architectures, and we choose or we apply this architecture specifically for different types of applications. So here we will explore the CNN part, convolutional neural network part, because we are going to focus on medical data set, medical image data set. So it is an image, right? So mainly we will focus on the CNN part. So now if we'll talk about the convolutional neural network, then it's like we can say it's an extended version of artificial neural network. In artificial neural network, we have only dense layer, fully connected layer, but in convolutional neural network, we have some other different types of layers also. These layers are connected to each other, and for the connection purpose, we use filters. Inside the filters, we assign the weights, right, parameters, and we need to learn these parameters and biases, right? So once our parameters will be learned, then we can get the output. So the pre-processing required in a CNN is much lower as compared to the other classification algorithms. So we require very less pre-processing in a CNN part. So now, if we talk about the CNN layers, there are three main different types of layers in CNN. One is convolution layer, next is pooling, and another is fully connected layers. So if you talk about the CNN convolution layer, then the purpose of convolution layer is to find the feature, to extract the features using to extract the features from the particular data set. Now we have pooling layer. The purpose of pooling layer is to reduce the computational complexity of the model, right? So convolution layer is useful for improving the accuracy, but pooling layer does not play a major role in improving the accuracy. It is mainly used for reducing the complexity. I will explain about all these layers in detail. And then we have fully connected layer. Fully connected layer is used for classification purpose, right? So I will explain like how we can use the softmax and sigma and all those things. In front of you there is a LeanNet architecture. This is the smallest deep learning architecture. LeanNet is the smallest deep learning architecture in which we have input image, and we have we apply convolution layer, and then we apply pooling, then again convolution layer, again pooling, like that we connected layers we apply. So in upcoming slide, I will explain about each of these layers in detail, and how then I will come back on this figure. Then we'll calculate how we are getting image size 28 cross 28 cross 6 from this 32 cross 32 likewise, okay, and how we are getting, how we'll get this 14 cross 14 using the pooling layer. So we'll explain, we'll discuss this concept in upcoming slide, right? So let's try to have an overview of this convolution neural network. So what we have in CNN. So first, for example, we give input in the form of image. So for example, we are giving input of car, or maybe we can give input of any medical image. Then we apply the convolution layer. So convolution layer will extract the features. Then after convolution layer, we apply the ReLU activation function. The purpose of convolution layer is to extract the feature. Then after extracting features, there might be possible like few features are important, few features are not that much important. So we use activation function. Activation function are used to activate a particular neuron or particular features. Like if particular feature is important, then assign higher weight. If particular feature is not important, then assign lower. So we can say it is used to bring it is used to activate a particular neuron. So we use ReLU. In it is not necessarily activation functions also, but ReLU is quite right. That's why mostly we mention about the ReLU. Then for pooling layer, as I mentioned earlier, to reduce the dimension. So for example, this is a very high dimension data set, like 4096 cross 4096, right? It's an image size, let's say. Then if we will perform CNN on this kinds of data set, then we require very high computational complexity. We require very powerful GPU, right? So what we can do, we can apply pooling layer on this. So pooling layer, it depends on the filter size, but most common is 2 cross 2 non-overlapping pooling. So if you are applying 2 cross 2 non-overlapping pooling, then it will convert 4096 to 2048 cross 2048, means it will reduce the size to half. So it will be huge relax on the model, and we can use this computational complexity for other purpose, right? Likewise, we can apply again pooling, then 1024 multiply by 1024 will get, right? So this is the way we can use the pooling operation. Then again we apply the convolution operation, and here the same convolution operation we apply, then pooling. Now there might be one question in your mind, why we are applying this convolution pooling again and again, right? So the answer is, in the beginning, whatever convolution we are applying, it will produce only low level features. Low level features means, for example, it will give you pixel information, little bit age information, or like something. So we will not able to clearly identify what is represented in this image, right? So to get the clear features, we need to use few more convolution layer like that. So here there is a dot dot dot, because we don't know how many convolution and pooling we need to apply. It completely depends on particular data set, right? So if data set is very much complex, then we need to use too many convolution layers. If data set is very simple, then fewer convolution layer can work. So initial convolution layer will produce low-level features, but as we will move towards the right-hand side, it will produce high-level features. In high-level features, we can clearly see the features like what is there in that one. Now, pooling layer, you already know, like, so we are repeating, we are reducing the size again and again. Now, after this, after convolution layer, we need to apply the fully connected layer. So the purpose of fully connected layer is to do classification, right? So it is used for classification. And here, for fully connected layer means it is dense layer, and dense layers are work only with a one-dimensional data set. So this is an image. So image means it's a two-dimensional data set, right? It's a 2D dimension, two-dimension data set. So what we need to do? We need to convert that 2 dimension to 1 dimension. Then only it will work. So for conversion purpose, we use flattening operation, right? So we flatten that one. So flatten means just simply convert 2 dimension to 1 dimension. For example, we have image like this: 2, 4, 8, 10, 5, 6, 1, 8. Let's say this is an image. Then if you want to convert in 1 dimension, then in 1 dimension it will come like this: 2, 4, 8, 10, 5, 6, right? Like that. Okay, so in a 1 dimension, we can write 1, after that 1, and then we can write 8 like that. Okay, so in a 1 dimension way, like we can represent this image. This operation is called flatten. Now, after flattening, we can represent the fully connected layers. So fully connected layer means each of the neuron will be connected with other one, and these will be connected with weights like W0, W1, just like in artificial neural network. And then we get the output. Now, there are some other important information in this diagram. Like, for example, we are using output layer. In these, in these layers, like in this one and this one, not in this one. Like in these 2 layers, we can use number of neuron as per our requirement, right? As per the complexity of data set. But in final layer, means in this layer, we need to use fixed number of neurons. For example, it's a multi-class classification. We are classifying different types of vehicles, like 10 different types of vehicles are classifying, like car, truck, van, bicycle, bike. Then we can have only 10 neurons here, right? Maximum, not maximum, exactly 10 neurons. So 10 neurons should be there, like one for car, another for truck, next for van, like that, and next for bicycle. So in this way, we can see this architecture. And if it is a multi-class classification problem, then in final layer, we apply the softmax activation function. It's fixed, right? If it is a binary classification problem, then we apply the sigmoid activation function. So if you are talking for softmax activation function, that means softmax activation function generates the probability corresponding to each of the class. So as in input, there is an image of car. So here, like softmax activation function will generate higher probability for car, and a lower probability for truck, van, and lowest probability for bicycle, because the features, whatever features we will extract from convolution layers, and these features will match with the car, right? So for car, it will produce highest probability, and according to highest probability, we can say, like in this image, there's a car. So this is a basic processing, high-level overview of convolutional neural network, how convolutional neural network works. Now, next, let's understand the convolution operation in convolutional neural network. So for applying the convolution operation, like for example, we have this image, and on this image, we are applying the filter, right? So if we will apply the filter, then this filter will be applied. This filter will be applied on this part, right? One by one, it will be applied. For example, like we will start from this place. So this filter will overlap here, and element by element we will multiply here. This way, right? This one. Element by element will multiply. 0 multiplied by 4 plus 0 multiplied by 0 plus 0 multiplied by 0, like that we'll do. And in last we'll get the answer. So center pixel 1 will be replaced by -8, like that we'll do, and we'll drag the window for next part, and like that. So this is the convolution operation. We'll discuss this thing here in detail. So there are 3 layers in convolutional neural network. So I'm going to discuss about the first layer. In a first layer is a convolution layer. So let's understand the convolution layer with one example. So let's say we have 5 cross 5 image, right? This is a 5 cross 5 image. We have 5 cross 5 image, and I'm telling it 5 cross 5, not 7 cross 7. I will tell you the reason. So if this is 5 cross 5 RGB image, red, green, blue, right? 3 channels are there. There are 3 channels RGB. Now here, if there are 3 channels in image, then there will be 3 channels here also. Like, so why? Because like each of these filter value will be applied separately. There will be 3 channels in the filter also, like so W0. At this moment, forget about this, right? I will explain later on. So W0 is the one filter in which like the size of filter is 3 cross 3, but as there are 3 channels in input image, that's why 3 channels are here. Now filtering, how filtering work? Like we overlap on the particular value. So if we will consider image like this, right? If we consider image like this, that means that will overlap here. Let me take a different color. Here, like we overlap this part, right? And we will overlap. That means the center pixel should come on the center part, right? The center part. So we are overlapping on this part, right? In case we don't have these digits, right? These bits, right? In case, let's suppose like we don't have these bits, then what will happen? We will overlap on this part, then we don't have this digit, then our like mathematical calculation will produce an error, right? It will not be effective. Either then in that case we should start from this place, then it will be okay. So what we don't want to reduce the dimension, so we overlap here, but additionally we add the padding bit, right? We add the padding bit towards the edge of each of the particular pixel value. So let me show this again. Like for example, we started with this pixel. Now this 3 cross 3 window will overlap, and element by element we will multiply, like 0 multiplied by -1 plus 0 multiplied by 0 plus 0 multiplied by 1, like that. Okay, so continuously we will multiply for all 9 values and we'll get the output, right? Continuously we will multiply all 9 values and we get the output. So element by element we are multiplying, then we are getting like if we multiply, let me do one for you. Like for example, 0 multiplied by -1, so it will be 0. I'm writing 0 only. 0 multiplied by 0, it will be 0. Plus 0 multiplied by 1, it will be 0. Likewise, everything will be 0 because all are 0 except this one. So 1 multiplied by -1, so it will be -1. So if we will do the summation for all these 9 values, I did not write, right? Okay, it should be 9 because 9 are there. So we'll get -1, so -1, right? -1 here. Now similarly, we apply this part here. So in this case, it will overlap on this part. Then element by element we can multiply. So just neglect the 0 part, just non-zero part will take care. So 2 multiplied by -1, so -2. 1 multiplied by 1 plus 1, and 2 multiplied by 1 plus 2. Or 1 multiplied by 0, so 0, so we are getting 1. Okay, so we are getting 1 here. In the same way, we can do this thing and we can apply this part here. I hope you understand. If you have a question, please just ask me. Just unmute and ask. Okay, if you have a doubt and confusion. So we can neglect the 0 part because that will be 0 only. So just take care about non-zero. 2 multiplied by 1, 2. 1 multiplied by 0, 0. So either we can write or we can leave. and 1 multiplied by -1, so -1. So we'll calculate, it will be 1. So we can write a 1. So we got the output, and then in last we will add all these 4 terms, right? So if we add, then -1 to +1 cancel out, 1 plus 1 2. That's the reason we are getting 2 here, right? So next, this is the one of the convolution operation. Next, what we can do next, as per the by default rule, we need to move from this pixel location to this one, right? It is a by default where stride equal to 1, but but in this case we have stride equal to 2. When we have a higher stride we have when like our image dimension is very large size of image dimension, then we can use a higher stride, so they can reduce the size of image. So in this case we are moving from this point to this point. Okay, we are moving from this point to this point, then we are moving from this point to this point, like that. Okay, so this is the way we can jump on and we can go from one place to another place. And then after this like stride equal to 2, then we will move from this point to this point, this point to this point, right? Because stride equal to 2, this point to this point, this point to this point, like that. Okay, no, this one not like this. So in this way we will cover on, and once we will cover everything, then we'll get this complete image, complete extracted features. So these are the features. Now this is for W0 we did, and now same thing we can do for W1. So W1, like same thing will be repeated. If you will apply for W1, then we get this one. So now why we are applying, why we are using like 2 filters? Why only one filter will not work here? Because if you're talking about image data set, then there might be 2 different types of features. Like simple example we will take, then like for example in an image there might be horizontal features and there might be vertical. Horizontal edges, there might be vertical edges. So W0 will detect horizontal edges, W1 will detect vertical edges. In reality, there are like hundreds of features, right? Hundreds of features, or like more than 2 features are available in image. So to get all those features, we need to use that particular number of filters, right? So if like for example 50 features you need to use, 52 features you need to use 52 number of filters, right? I hope it makes sense. So different number of features you will get using that different part. So in this case we have stride 2, I already mentioned, I hope you understood. Filters 2, W0, W1, channels are 3, RGB, and padding is 1. So padding, we added 1 bit padding towards this one. Okay, so this is the way we can work on, and we can work on convolution layer. So this is one of the example of convolution layer where we can apply. Now the question is, for example, somebody ask you if input size is n, filter size is f, then output size will be n minus f plus 1 cross n minus f plus 1. This is the output size. This formula is applicable only when we have padding 0, sorry, and stride is 1. This is the by default case. When we have padding 0, stride 1, then this formula will work. So this formula will not work here, right? Because we have padding 1, stride 2. But this formula can work on this diagram. Here, like we have n equal to 32 image, and we have f equal to 5 here. It is a 5 cross 5 filter. We have f equal to 5. So if you will apply the formula n minus f plus 1, right? So output size will be n minus f plus 1 cross n minus f plus 1, means same. So here n is 32, f is 5 plus 1, right? So it will be 28. So our output shape is 28 cross 28. That's the region, right? Now here we are getting 6 because we use 6 number of filters. Like here we use 2 filters, W0, W1. That's why we got 2 outputs, 1 and 2. Likewise, in this example, we are using 6 filters. That's why the shape is 6 cross 28 cross 28. You can write cross, right? Just we want to differentiate between number of filters and image size, image resolution. That's why at the rate is mentioned, but you can write cross, no problem. Now, after applying pooling, we are getting this one. So I'm not discussing pooling at this moment, but after pooling, again, we are applying convolution. So for this convolution purpose, we have n equal to 14, f equal to 5. So n minus f plus 1 we will do, then we'll get 10, right? So we'll get 10. So our output size will be 10 cross 10, and we are using 16 filters, right? So 16 cross 10 cross 10 we are going to use. This is the way we can use, we can get the convolution layer. I hope you understood. If any question, please let me know. Now, this formula is applicable when we have padding 0 stride 1, but what will happen when we have some value of padding, some value of stride? So if you have some value of padding, then this formula will work, n plus 2p minus f plus 1. And when you have a stride also, then n plus 2p minus f divided by s plus 1 multiplied by this one, right? So in this case, this formula will work because we have padding and stride value. So our formula is n plus 2p minus f divided by s plus 1, right? This is the formula. I'm writing one dimension only, like because next second dimension is same. If our image resolution is same. So n is 5 here, right? 5 cross 5. N is 5 plus 2p. P is 1, right? Padding 1. So P is 1. F is 3. 3 cross 3 filter. And divided by 2 plus 1. Okay, so 5 plus 2, 7 minus 3, 4, divided by 2 is 2 plus 1, 3. So we get 3. That's the reason we are getting 3 cross 3 output matrix. Okay, so this is the way like we can work on, and we have 2 filters. That's why we are getting 2 output. Now another one is like the output shape does not, the output size does not depend on number of channels. It depends on number of filters. So here we have output, right? We have output. So here we have channels 1, 2, 3. We have 3 channels. So output shape does not depend on number of channels. Here obviously there are 3 channels, but we have 2 outputs, right? In place of 3, like if channels are 20, but still we will get only 2 outputs. Where like on what point like output output depends? Output depends on number of filters. We have 2 filters, that's why we are getting 2 output. I hope it is clear. So in this way we can see our output shape will be n minus f plus 1, n minus f plus 1 cross nc dash, nc dash, where nc dash is the number of filters, nc is the number of channel. Now parameters, one of the very important point in this convolution neural network, number of parameters. So number of parameters, let's understand with this diagram, then it will be easier to understand. So number of parameters means total values in filters. So here like we have 9 values, here also we have 9, here also we have 9. Total values are 28. 9 plus 9 plus 9 plus 1, 28. Here also we have 28. 28 plus 28 equal to 56 values. So in this small architecture, we have 56 values. Likewise, if you have 10 filters like W0, W1 to W9, then how many parameters value will have? 28 multiplied by 10. So 280. Okay, so we will have like 280 number of values here. 280 number of filters. So here I explained if you have 10 filters and we can have a 280 number of values. This is the way we can calculate the number of parameters in any of the deep learning algorithm. Now after this we have activation function, as I showed you in this diagram, like ReLU activation function we use. So let's have a quick overview of activation function. There are different types of activation functions are there, linear, non-linear. So mainly we are we focus on non-linear activation function because they bring the generalizability in our model, right? They make our model general. So like these are the most common activation function in front of you, like sigmoid. Mostly like we use sigmoid for binary classification in the last layer. The sigmoid shape is just like S, and all values are in between 0 to 1, and in center we have value 0.5. 0.5, right? The same way we have 10 hyperbolic, -1 to 1, ReLU, right? Leaky ReLU, max out, and ReLU. Like different activation functions are there, and they have specific purpose based on their requirement. Now, pooling. There are different types of pooling operations are there. Max pool, min pool, average pool, median pooling. But mostly we use max pooling because using max pooling, we take out the maximum value. Now for pooling purpose, we have 4x4 window, and here 4x4 maximum we will apply. So maximum we will apply, that means we will take the maximum value out of this. So maximum is 9, right? So we can take the 9. Now next is 2x2 max non-overlapping. Non-overlapping means like we have this part, right? 2x2. So from this window we'll take maximum. This is 5. Then this is no one overlapping, so we will not overlap. This part here is 6, so we'll take 6. Then again we will take non-overlapping. Here is 8, and here we have 9. Okay, so in this way we can do the 2x2 max pooling. And if you overlap, right, that was the overlapping. So overlapping, this is the most important pooling operation, 2x2 non-overlapping. Now we can have overlapping also. So if you will have overlapping, that means we will overlap 2x2 only, but overlap. So here 5, then we will overlap like this. So here again 5 maximum, and here we will overlap here 6. Like that, 5, 5, 6. Then again we'll overlap here. So 8, like that. We will repeat the things, and we'll get the 3x3. So in this way, like we can represent the max pooling, 2x2 max pooling, overlapping and non-overlapping. And if you want, you can apply the same formula, n plus 2p minus f divided by s plus 1. This formula will work, right? As we applied in a convolution layer also. So this is a pooling, and pooling is a very simple operation just to make size half. So let's discuss this again. Like we got the convolution output like this, then we applied a pooling operation. So what pooling operation do? It makes the size half, like 2x2 non-overlapping. So 28x28 will become 14x14. The important point is pooling operation does not change number of filters. Whatever number of filters are there, it will produce the same number of filters, but image size will be halved, right? Will be halved. In the same way, we are getting 14x14, and after that, if we apply pooling here, then we are getting 5x5, and number of filters will be same 16. Right? So this is the concept of pooling layer. Now after pooling layer, we have fully connected layers. It is just like a neural network. And here the fully connected layer means we have flatten, right? So once we apply the flatten, we get the one-dimensional matrix and one-dimensional vector, and that one-dimensional vector will be will be multiplied with others, and like we can write W0, W1, W3 like that. We can write class ABC. We can classify, right, like that. So this is the way. And in last layer we will use softmax. I already told you why we are going to use softmax, because it's a multi-class classification. It's a binary classification. Then we can use sigmoid, right? So this is the way we can work on, and this is the complete explanation of convolutional neural network. And in this diagram also, like we can see, we are using convolutional neural network in last layer, right? Last layer. And here outputs are 10, because this data set is an MNIST data set. In MNIST data set, we have 0 to 9 digits, or 0 to 9 like alphabets, 10 alphabets. So we need to classify those 10 alphabets, right? So this is a way we can work on. Now that I already explained, we use softmax activation function in the end, because softmax generates a probability corresponding to each of the class. So different CNN architectures are available, like LeNet, LXNet, BGNet, GoogleNet, ResNet, right? So we use this architecture for like specifically for transfer learning purpose. These architectures are already trained on very large data set like ImageNet, and after training, different industry, different companies uploaded these trained model weights on the cloud, and we can directly download these weights and we can use in our case if you don't have a sufficient data set, if you don't have a sufficient GPU resources, right? So for make our like computation easy, we can use these architectures. Now let's understand about like unit model. So we discuss about the CNN part, which is very much popular in different application areas. But when we talk about the medical imaging, in medical imaging field, we need precise output, right? We need very precise output. So because we play with the life of human being. So if we play with the life of human being, then our output should be very much accurate. So our output should be very much accurate. That means our model should be like advanced. We can apply CNN on medical image data set, and people are still applying. But for getting precise output, one more variant of CNN is available, that is called unit model. Why we call this unit? Because the structure, the shape of this model is just like a U. And here in this unit model, we have same CNN and pooling and all those things. Like we have input image, the size of input image 572 cross 572, and we have one channel, that's called grayscale. This is a grayscale image, that's why it's a one channel. If we write is 3, that means it's a color image. So here this is a 1. Okay, so one channel, right? This is a one channel, so it's a grayscale image. It's a medical image or whatever image, it's a grayscale. So 572. So n equal to 572 here. N equal to 572. Now, after this, we apply the convolution operation. You can refer from here. This is a convolution 3 cross 3 filter. 3 cross 3 filter convolution operation. So as I mentioned earlier, if you apply convolution operation, then our output size will change just like a formula. With formula n minus f plus 1. When padding is 0, standard 1. Right? So n minus f plus 1 will be the output size. So just keep 572, n equal to 572. 572 minus 3 plus 1. If you do this, then you will get output 570, right? So that's the reason we are getting 570 cross 570 here after convolution operation. Now we are getting 570 cross 570. That's very good, but we are applying 64 filters. Earlier, like we applied 2 filters, W0, W1, then we got 2 outputs. Here we are applying 64 filters. What these 64 filters will do? They will extract 64 types of features, right? They will extract 64 different types of features. That's why we are going to apply 62 filters. Now, again, we will apply one more convolution operation, and this 570 n will be 570, f equals 3, so we'll get 560 cross 560. And again, we are applying 64 filters, we'll get output 570, 68, 568 cross 64, right? So this is the way we can get the output, and we can represent this 568 cross 64. This is a convolution operation. After convolution operation, we apply the max pooling that we discussed earlier. So you can refer from here, max pooling 2 cross 2 non-overlap. 2 cross 2 non-overlap. 2 cross 2 non-overlap max pooling we are applying. That means we will make the size half. So 568 divided by 2 will do, so it will become 284. You know, like how to make the size half, right? How max pooling do the size half. So 284 cross 284 will get. Then again we apply the convolution operation. So n equal to 284, f is 3, so we'll get output n minus f plus 1, 282. So likewise, we are going to repeat the same thing, max pooling convolution, like so many times. So at the end, we are getting 30 cross 30 or 28 cross 28. This part, this left-hand side part, is called encoder, right? This left-hand side part is called encoder. So encoder is to contextualize representation of information, right? To represent the information in a contextualized format, means in a meaningful format. So in other way, we can say here, whatever size we are getting 30 cross 30 or 28 cross 28, these are very high confidence feature, very highly useful features, right? Oh, okay, that's fine. We are getting very highly useful features. That's fantastic. But there is a huge difference between the size of 572 and 28. So we need to return back on the original size because if we want to represent the output in the same format, same dimension, right? Whatever input medical image you have given, then we will expect the answer output in the same dimension. So for returning on the same dimension, what we will do? We apply some other operation like up convolution we apply, and we apply the like up convolution, we apply the ReLU function, like that we apply, right? So what up convolution will do? It will make the size double. 28 cross 28 will become 56, and 52 will become 104, 1010, 100, 200, like that. Okay, or same convolution operation we are applying. So up convolution will make the size double. So now we reach at like 392, 392. Now there might be one issue here. The issue is, as we started from 572, we reached on 30 and 28. That means there are higher probability. There might be a very high probability that we might have lost some features, right? Because there is a huge difference between 572 and 30 cross 30 or 28 cross 28. So we might have lost some features. So to preserve those features, okay, sorry, I forgot to tell you, this part is called decoder, right? That is left-hand side encoder, this part is called decoder, right? So now to preserve those features, we use skip connections. We use skip connections between encoder to decoder for each level. So for example, this line, this gray line represents the skip connection. Skip connections means just we will directly copy the half of the features to here. So here you can see the white part. The white part is copied version, copied from left hand side. In the same way, we are copying half, we are copying half here, right? So this skip connection will be useful for preserving those features, right? To preserving those preserving those features from left to right side, right? So this is the working of unit, and same we can go. And in last we have 2 because it might be a binary classification problem. So we have like class size 2 in the end, right? So I hope you understood about the unit model, which is mostly useful for medical imaging. Now, if you will talk about this different applications of CNN where we can apply, then we can do for image and signal classification. For example, given an image signal, produce a label. We can produce a label like computer-aided decision system. We can make like help human operator in taking decision, continuous monitoring purpose, screening purpose. We can use like reduce number of unnecessary exam, reduce number of missed detection. This is a huge like major problem in medical domain. Unnecessary exam purpose, right? Means like whatever CT scan, MRI, the radiologist takes. Like sometimes like these CT, MRI are not very much visible in a proper condition. So what we need to do? We can reduce the unnecessary exam using that CNN part, using that classification thing, right? So this is one of the application. Another application in biomedical applications like tumor detection for MRI, CT, X-ray, diabetic retinotherapy detection, skill lesson classification, ultrasound classification, Parkinson disease detection. Like for many other purpose, we can use this CNN and unit. And semantic segmentation purpose like partition and image signal and multiple segmentation. Image segmentation, I hope you understand, means image segmentation means separating the foreground from background. So that we can use similar to classification, but a label is assigned to each pixel of image. So here, we can apply, we can highlight region of interest, compute volume is how much large that tumor is, surgery planning, or so many for different purpose. We can use this thing. We can use like MRI tumor segmentation, electronic light microscopy segmentation, Hertz sound segmentation, right? For different purpose, we can use this particular application. Now, after looking all these applications, now I would like to discuss a few of the work related to medical imaging and how effectively we can apply this. How effectively we can apply this unit or other architectures, unit inspired architectures for like medical image domain. So here I'm going to discuss about one of my work that was proposed recently, that was published recently, and here we have applied unit architectures, means unit inspired architectures for knee MRI segmentation purpose. And we used multiplanar volumetric segmentation, means we divided that 3D knee MRI image into multiple volumes, and according to that we segmented that image, and we validated that model using different extensive quantitative evaluation techniques, right? So this is a unit architecture we applied. Then okay, let's see first. And for that work purpose, we collaborated with radiologists in Copenhagen Hospital, Denmark, and they provided a private data set to us. They validated our results, right? They provided input, and they are still using this work for their research and for other work purpose, right? So to understand this work, let's start with the block diagram. So in this work, like we have knee MRI image. It's a 3D image, 3D knee MRI image. In this 3D knee MRI image, this work was applied on 3 data sets: OAI, CCVR, and LIRA. So this is the OAI data set. OAI data set in which we have 7 cartridges or 7 classes. Now we have this 3D image. Now what we need to do, we need to divide this 3D image into multiple planes. So if you want to divide this 3D image into multiple planes, then these planes will be generated randomly from different angles, right? So for example, we have total 360 degree, and what we are doing, we are taking the difference of 60 degree, right, to cover the complete 60 degree. So we want at least 60 degree difference should be there from one plane to the another plane, and with that 60 degree difference we are taking the slices. So now we have taken the 3D image. So 3D structure you can understand with, like, for example, loaf of bread, right? We have complete loaf of bread, that means that is 3D. So let me show you that loaf of bread, then you will understand in a proper way. Loaf of bread, let's say. So if you see the image of loaf of bread, then like this is 3D, right? This is a 3D structure. Can make it large. Like this is the 3D structure, right? It's a loaf of bread, 3D structure. Now you can assume this is a 3D image, 3D medical image. Now from this 3D structure, we can take out the 2-dimensional slices. So 2-dimensional slices we will take, then it will like a bread here. Slices, right? Slices. So like we are taking 2-dimensional slices. These slices we can other directions. Also, it is not concept is applied here. like we have 3D MRI image, 3-dimension structure, and from that 3D structure, we are taking 2-dimension slices from different angle, right? So these are the different angles you can see, from this angle, from this angle, from this angle, from this angle, like that. We are taking the 2-dimension structure from this. So these are the extracted slices. These are the extracted slices from the image. These are the extracted slices from the model, right? These 2-dimension slices, we give these 2-dimension slices to the particular unit model as an input. Now, once we give 2-dimension slices to a unit model, then what unit model will do? It will segment. Unit model will segment into different part. So as there are 7 classes here, I told you this is a AI data set. So 7 cartridges, 7 classes are there in knee MRI. So like this unit model will divide the slices into 7 different parts, into 7 different parts, into 7 different parts. Next, in 7 different parts it will divide. So here we can see like 7 different parts, and each part will represent a particular class. Each part will represent a particular class. So there are 7 different cartilages, like medial tibial, medial femoral, lateral tibial, lateral femoral, like that 7 cartilages are there. So you can see the 7 different colors. Now, how these colors are like visible? Why these colors are visible? Because like as I mentioned you earlier, if it's a multi-class classification problem, then we apply the softmax activation function, right? We apply the softmax activation function. So what softmax activation function do? Softmax function like generates the probability corresponding to each of the class, right? It generates the probability corresponding to each of the class. So there are 7 classes. So 7 different probabilities will be generated. 7 different probabilities will be generated from each of the class. So now, here we can generate the 7 different probabilities, 7 different probabilities, 7 different probabilities. Each color is representing the one different particular type of probability value. Now, one important point is, in whatever way, in whatever structure we are looking these images, we will not get these types of structure because we access from different directions. So actual structure will not be like this. So to make a structure like this, we apply the nearest neighbor interpolation. Before this step, we apply the nearest neighbor interpolation. After doing the nearest neighbor interpolation, we got structure something like this. Okay, so this is just a representation. Now we got the structure like this. This one is not the complete 3D output, right? Here the outputs we are getting from slices. So as we have given input as a 3D data set, so our output should also be 3D. Our output should also be 3D. So to make it 3D, what we can do? We can fuse the output, right? We can fuse the output. So for fusion purpose, what we can use? For fusion purpose, again, like we applied the neural network, right? So fusion model we built, we constructed, then on that we apply the neural network. So in neural network, what we want input and we want weights, and we generate the output. So here input will be the generated probability. Like as I mentioned you, from softmax we are generating probability. So these probabilities will be generated, will be work like a input. Now we get weights we generate randomly. Neural net biases we generate randomly. So likewise, we trained those weights and we fused the model. And once we fuse the model, we got this structure, right? This is a complete 3D. So input was in the form of R V comma V cross K. V is the sample, and V is the dimensions, like six dimensions are there, like 1, 2, 3, 4, 5, 6. So V is the plane, we can say. So 6, K is the number of classes, 6 cross 7. Then our output will be R to the power 7, means just 1, and we are getting 7. Now, once we got this, then R, W, H cross CH, width, height, and channels are 3. then we are getting W cross H cross K, width, height, and K is the number of outputs. So we have 7 classes, then we are getting 7 different outputs. So this is the way like we can work on multiplanar unit 2+ model, and we can get the output. So this is the complete work that like we did. And here in this work, like we applied different variants of unit. We applied unit 2+, unit 3+, unit 2+ deep supervised version, unit 2+ version. Different variants of unit we applied, but our model was giving highest accuracy for unit 2+. That's why we mentioned unit 2+ here. Additionally, we applied our model on different number of planes. For example, here there are 6 planes, right? We visualize the 6 planes here, but we tested our method for 3 planes and 1 plane also, right? So, but for 6 planes we were getting good accuracy. That's why we mentioned 6 planes in our block diagram. Okay. So this is the basic mechanism behind this unit. Here you can see the extracted slices from different angles, right? So from one angle you can see, and here we can see for the multiplanar, from multiple planes we can see. Now for calculating the accuracy, we use dice score, and the dice score was calculated like this. First of all, we extracted the 6 parts for 6 6 planes, and then we fused this one. We got the output, and that output was compared with the true output using dice score, right? So we calculated the accuracy here. Now, as I mentioned you, we applied different unit architectures. So here it is the example of simple unit model that I explained you earlier. Like you can see here, the simple unit model, right? Just in short form, we represented there. Where like we have encoder, we have decoder, we have skip connections. Now, after this, we have we applied our model on unit 2+ also. This is unit 2+, where we have full scale skip connections. Means we have encoder, we have decoder, and we have medium coder also. Right, medium coder also. So encoder, decoder, medium coder. So why we need this unit 2+? Because if you are using simple structure, then here it might possible, like although we are using skip connections, but it might possible we might have lost some features still, because we are taking half features from here to there. So to preserve most of the features, what we are going to use, we are using medium coder, encoder, decoder, medium coder we are going to use, and using this medium coder we can preserve these features, right? So unit 2+ we are going to apply, and now we have unit 3+. In unit 3+, what we can have encoder, decoder, and the structure of unit 2+ and 3+ are more or less same, but they represented the skip correction in a different way. If you see carefully, then both are same. So they painted skip connections like this, right? Just in this way, and everything is same. So here in unit 2+, we are getting output from last node. Here also we are getting from last node. Additionally, apart from these 3, we have we tested our model for unit 2+ deep supervised version. In deep supervised version, we got output from this 4, right? This output from this 4, and we applied the maximum likelihood, and we got the output, right? So this, in this way, like this is the deep supervised version, and here also we did this one thing. So here maximum likelihood function ML, right? And we got the output. In this way, we tested our method for 5 different variants of unit, and in our case, unit 2+ basic version was giving the highest accuracy. That's why we focused on basic version. Now, If you see the things in a mathematical way, then we have input size like R W H cross CH, but we are generating segmented output H R W H cross K, width height K. You can see in this diagram also. So W cross H cross CH, W cross H cross K. See, right? So this is segmented output. So segmented output means this is S1, this one is S2 till S6, right? So 6 segmented output we are getting. So that we can see in the mathematics part rather. Also like S equal to SV. V will vary from 1 to 6 if there are 6 number of planes. So S1 to S6 that belongs to W cross H cross D cross K. Width, height, depth, and class, right? Number of classes. So in this way we can represent V belongs to V. If we are 6 plane, the value of V will be 6, 1 to 6. Now, next part is fusion. So as I told you, in fusion we applied the neural network. So for applying the neural network, what we did, this is the equation of neural network, optimization function of neural network, where like WKC, PKXC multiplied plus beta C. So WKC and beta C are the randomly generated weights, and the input is the probability generated from the softmax activation function. So PKXC is the probability of class C at voxel X predicted by segmented SK. In 3 dimension, we call pixel as a voxel, right? Because it's a cubic. So like that probability that was generated previously by softmax, that probability we consider as an input, and we train the model for fusion purpose, right? Beta and WC like that. So this model was tested on like 3 different data sets: OAI, CCVR, Lyra. OAI is a publicly available data set, but CCVR and Lyra are private. And first time this Lyra data set was applied on our method, right? Before our work, no paper, no research article was available on Lyra data set. So all 3 data sets are collected from Copenhagen patients, and that particular hospital only collected. So earlier, like OAI was also private, but that hospital made that public. So nowadays OAI is public. So there are number of scans, 61, 40, 39, and slices are there. In OAI there are 7 cartridges, CCVR 2, in Lyra we have 5 cartridges, and different scanners are there, prototype, protocol, and FOU, and so many things are there. And these all parameters we received from radiologists, right? So even for like scanner type, I cannot explain in the detail because this is just medical things. So this is company name, Siemens 3T or Istode 0.180 like that. Now this is the performance comparison in the form of DICE score. So here you can see the performance of 3 planes, 6 planes, and number of parameters. Here we are getting DICE score, time. So this is training time, 93 hours, 26 hours, 47 hours, like the training time. And for 6 planes also, like we have a time and all those things. So in our case, our performance is significantly higher than others, but our performance was not that much higher, like it's a huge difference. So for that purpose, what we did, we applied a pair t-test, which comparison we did. So using that pair t-test, we compute the pair t-test on Lyra dataset, and we computed it at 5% level of significance. That 5% level of significance means like there are 2 hypotheses, null hypothesis and alternative hypothesis. To prove that our model is performing better than the other, then our alternative hypothesis should be true and null hypothesis should be fake, to fail. So if the value of this pair t-test is less than 0.05, means because we are measuring at the 5% level of significance, if less than 0.05, yes, 0.05, then we can say like our model is performing better than the other. So in most of the cases, the value is less than 0.05, less than 0.05. In most of the cases, less than 0.05. In few cases, it is greater than 0.05, just greater than 0.05. So that's a way we can say like our model MPUNet 2 plus is performing better than MPUNet, right? Now to prove the performance like in more generalized way, to prove the performance in more effective way, what we used, we plotted the box plot. So we plotted the box plot for only 2 cartilages. So for plotting the box plot purpose, what we did, if you see this data set, these 2 cartilages are common. Medial tibial and medial femoral. These 2 classes are common in all 3 data sets. So we combined the dice score of these 2 classes from all these 3 data sets, OAI, CCY, LIRA, and we made one large data set. We made one large output, and we plotted the box plot for that mix output, right? Separately for medial tibial and separate for medial femoral. So here you can see this is for medial tibial MPUNet 2+, and here medial tibial MPUNet. So now clearly you can see our method is performing better than the previous one, because if you don't know the box plot, then this is 100 percentile, 75 percentile, 50 percentile, 25 percentile. This is mean, this is median, and these are the outliers. So we have less number of outliers than others, and we have higher mean, higher median, higher other percentiles, right? In the same way, if you compare medial femoral, here also we are performing better than the others. So in this case, we can say our model is performing better than other in general case also. So these are the statistical information from box plot. So we can skip this one, like whatever numerical computation. Now, sometimes it might possible that particular class performs very well, but other class does not perform very well. So what we did, we tried to we plotted the class-wise accuracy. Class-wise accuracy means for AI class-wise, CCVR class-wise, LIRA class-wise. So in CCVR we have only 2 classes, just 2 values. In LIRA we have 5, so Y values like that. So in most of the cases you can see the dice score is greater than 0.8. And for such data set, for such a very complex data set, if you're getting dice score greater than 0.8, that's very good. That's considered as very good. Just here we are getting 0.782 because this medial femoral cartilage is hidden inside the other cartilage, so it is very difficult to segment. So, but still we are getting 0.782 performance. So class-wise also it was performing very well. Now we did the visualized comparison also, like qualitative evaluation, because without qualitative evaluation, the complete things will not be they will not be complete evaluation. So for that purpose, we compared the ground truth. So this is the ground truth, this is our method and other existing method. So here clearly we can see our method is better than the others. Like here, there's a problem a little bit, but better than this one, right? So our method is better than the other. So we compared this one. Now, as we worked on 3D data set, right? 3D NMRI data set. So our output should also be in 3D. But it is very difficult to visualize the complete 3D structure. So what we did, we played a trick. So trick means we projected the 3D output on the 2-dimensional plane. So we projected the false positive from each of the cartilage. So let's say this example is for false positive from medial tibial cartilage in OAI cohort. So these are the projected version. So this color represents the number of false positive. So we are 10, 8, 6, 4, 2, 0. So number of false positives, here we can see the dark yellow color. Here we have little bit light. That means we have less number of false positive, right? So here you can see the darker yellow types, yellows. Here we little bit like that one light yellow. So it's a less number of false positives. These are the average number of false positive per slice. Now, similarly, here you can see the darker side, and here is a larger side. So in this way, we can see, we can compare, we have less number of false positive and less number of false negative for each of the cartilages. In the same way, we compared here. Clearly, you can see the clear difference here. We have little lighter yellow. Here we have little darker yellow. So darker yellow means we have large number of false positive in previous one. In the same way, like we did for all the cartilages and for all the data sets and for false positive and false negative, right? So this is about this work, and the performance was very high. If you talk about the comparison conclusion, then we performed this experiment on 136 number of planes. 136 number of planes, total 30,400 number of slices were used for this work purpose, and we collaborated with this particular hospital, and first time the Lyra has been applied, and we did extensive quantitative and qualitative evaluation with many of the different things like diagnosis score, purity test, other slices, and all those things. And so this is our the conclusion of this work. Now, let's discuss about another work related to unit only. Can you please mute yourself?
Sir, you're muted, sir. Sir, kindly unmute yourself, sir.
Yeah, I'm unmuting. My organizer muted me, and they muted all everyone. So stop presenting, and it's okay. Now, can you hear me?
Yes, sir.
Okay, that's fine. So now, like here, we are using unit in different way, like encoder and decoder. So you can think like how we can apply unit. Like for example, here is an encoder part, and how encoder is related to decoder, and we are using ASPP block. Along with that, like output of this encoder will be given as an input to another one, and here like we are using another encoder decoder, and we are getting output from first encoder also to the decoder, right? So you can see like how people are changing the architecture to improve the performance, right? So it's very simple, right? Just the two unit models have been combined, and they produce the like output. They tested the method or method on different like data sets. So like this is another like data set. They test it on poly data set, and they can get the accuracy like that. Okay, so another one is this one. So in this way, like we can improve they improve the performance by applying the double unit architecture like that. Now another work we can see like dense subset unit model. Like earlier, like there was model dense subset model only, right? That was based on CNN, convolutional neural network. But now dense subset unit model came, where like in dense subset unit model we apply the inception on dense part, right? On like on the unit part. So dense means we are making the architecture uh, deep. Deep means like we are using lots of other like different things, like I will explain here. Like in place of CNN layer we are using one block. In place of pooling layer we are using one block, one block like that. Okay, so this block is called inception residual block. This block is called dense inception block, and we have downsampling and we have upsampling like that, and we are going to concatenate, right? And we have simple skip connections like that. Okay, so I'm going to explain these things in detail. Like for example, this is a like inception residual block. So this is called inception residual block. Here we have input, we have 1x1 convolution, 3x3 convolution, and we have batch normalization layer and one convolution like that. So it's a complete architecture we are using. In place of simple convolution layer, one convolution layer, we are using complete architecture in place of this part, right? Now, similar way, if you see the other architecture, this is called like dense inception block, right? Dense inception block means this one. Dense inception block, this block. So this architecture is this one. Here we have input, inception residual block, batch nor bottleneck layer, inception result, bottleneck, like that. Then here also we are using inception result block. So this inception result block is this one. So now you can assume, you can see like how deeper we are going in a hierarchical way. Like this architecture will come here, and this architecture, compute this architecture will go there, right here. Now this is also an inception result block, and this one is also inception result block. Here the difference is we are using 3x3 convolution, right? You already know the filters convolution, but in this case we are using 1x3 convolution, right? Or 3x1 convolution. 1x3 convolution means here we are focusing on the column part more. Here we are focusing on the row part more, right? But other things are same. So we will combine the things. Now if you see the downsampling and upsampling block, so downsampling in place of simple max pooling, we are using this downsampling block. So in here we are using input max pool 2D, 1D, convolution, like that, 1D and all those out there. So this is called downsampling block. If we are looking for upsampling block, the upsampling is just opposite of that downsampling. So we are starting with input, upsampling block we are taking, 1x1 convol, transpose we are taking, and all those things we try to do, right? So we are going in a reverse direction with the help of this upsampling one. So now just imagine if we will combine the complete architecture, then how complex it will be, right? So we have one big architecture for this one, we have one big architecture for this one, we have one big architecture for this one, we have one big architecture for this one. If we merge all these things, it will be highly complex. But here the target is to improve accuracy, right? So, but obviously this architecture, for training purpose, we require very powerful GPU, right? So that's a region like we use this architecture. We need a powerful GPU, but like accuracy will be higher. So this model was tested on lung data set, and here there are the different results on lung data set. And here we can see the training and validation accuracy of different models. So this model, dense inception result model, performs significantly better, right? But like not that much good, right? But like the idea of that work was to explain you how that unit model can be applied in different way in different directions, right? So you can also think for your research, if you want to explore your research in medical domain, if you want to do research in medical domain, you can like use a unit, or there are other different methods are also there. You can use them, and they are quite popular nowadays, unit model, and it is not that much difficult also to do that. So if you want to work with me in collaboration, then feel free to contact me. So that's all for today's talk, and please let me know for any questions. So questions, I can see one or two questions in chat box also. How do we validate the performance of unit in medical imaging? So this is just for DICE score. We can apply just, it's a kind of classification, right? So we are segmenting. Segmentation is a kind of classification. For classification, what we can use F1 score, DICE score, precision, recall, right? Accuracy, true positive, true negative, false positive, negative. All these things can be used, but like DICE score is quite popular for segmentation. For segmentation, especially for segmentation, we should choose the DICE score. So for our performance evaluation purpose, we use DICE score. If you can recall, I told like for that NEMRI segmentation purpose, we use DICE score. So we can use the DICE score also. Any question? Any other question, please?
Sir, here can we use weight? For example, in case of we studied in neural network or in back propagation algorithm, sir, we are using some weight according to prior basis. if the probability of some point is higher, then we are using some weight. If priority is more, then we will give more weight. If priority is less, then we give less weight. Can we give a weight, sir?
Weight, like we can give weight in different like different algorithms, like we give weight in different ways. I'm not very much clear like for what weight you are talking about. In neural network we generate weight randomly, we give weight randomly in the initial stage, but later on we need to improve those weights with the help of backpropagation algorithm using loss function optimization and all those things. We need to improve those weights for each epoch in each cycle. So are you talking about those weights or something else?
Yes, sir. That weight, sir.
Yeah, so definitely here in unit also we apply the convolution neural network, right? It's an extended version of convolution neural network. And in convolution neural network, as I explained you, like we have filters, and in filters we have parameters, and these parameters are nothing, these are the weights. Just like in neural network we have weights W0, W1, W2. Here in convolution neural network and unit we have parameters, filters value. And these filters values are selected randomly in the beginning, but we need to train these values during the training phase. In the end, we are expecting like we are getting this final values of these. So definitely we use weights. So for your answer, to give you answer your question, yes, we use weights in this one.
Okay, sir. Sir, another question is, sir, you have mentioned that in this work, the application areas comes to medical, that is in MRI scan, sir. You told
Voice
MRI
is
scan.
breaking. Could you please repeat again?
Sir, one application area is MRI scan, sir, for today's lecture, sir. Sir, whenever frequently means sometimes I visited in the medical for MRI scan of some patients, sir. It is nearly taking one day, at least one day for MRI scan, sir. Sir, if we are using in this model, sir, approximately what time it will take, sir?
How much
But
time it will take
currently,
for training? What you are asking? How much time it will take for training?
no, sir, for MRI scan, sir.
Yeah, for MRI scan, what is your question? I could not understand. Sorry. Could you please type in the chat box because your voice is breaking? Just
Yes,
please
sir,
type in chat box.
voice is on. Yes, you do interactivity, sir.
Yeah, please
Sir, I
type
will
in
write it. Yes, sir, in chat box, I will write.
question if they have. Mr. Karamjit, please type in chat box, then I can answer.
Yes, sir, yes, sir.
Any other question, please?
Hi, sir.
Yes, please. Tell me.
Sir, this classification is the only image purpose. Can I use data sets, sir? This classification, LNet, the can I use prediction models, sir?
Definitely, like segmentation is a prediction only. Whatever, like we are segmenting now, we are segmenting. Okay, you are talking about that thing. Okay. Yeah, we can use
Numerical.
for prediction.
Can I
Yes.
use numerical
Yeah,
data?
we can do that.
Can I
We can
apply,
do that.
sir? This is models.
Yeah, brain tumor segmentation and brain tumor classification like that. You can do that using unit. No problem.
Okay, sir. Thank you so much.
You can use, yeah, for prediction purpose. Mostly you will use, like for example, brain tumor is a cancer or not. You will use sigmoid activation function
LNet
in the
model.
end. And, yeah, and you can train that model. No problem. You can use that.
Thank you so much. Thank you. Thanks, sir.
Yeah. Any other question, please?
Hello, sir. Sir,
Yes,
am I audible, sir?
Yes,
yeah,
ma'am.
yeah,
Yes,
you are.
ma'am.
Yeah, you are
Sir,
ready.
suppose I want to do I want to find spoilers of food using images, sir. Which kind of algorithms I need to use, sir? Suppose some cooked food images are there with me.
Which kinds of algorithm?
Through images, I want to find out the spoilers of cooked food.
Again, your voice is breaking. Is problem from my side or I could not hear your question properly, madam.
Okay, sir, I'll type in chat box.
Any other question, please?
Sir, Karmajit, sir, he has asked the question, sir. It is in the chat box.
Approximately, what is the time taken to scan an image of size? Scan an image. This is the task of radiologist. Image scanning task is the radiologist. It does not take that much time. Just click and done. If you're asking for training, that is a different thing. Training depends on what I showed you here. If you're asking for training, then your answer will be like this. Let me share my screen again. So if you see the timing, then I can show the timing of my work. Here we can see this size was 384 cross 384. Here 256 cross 256, and FOV was 140, right? And all those things. Now the timing was running that particular idea training time. But if you are talking for scanning time, then scanner is just but this task of radiologist, medical doctor. We don't do scanning, right? I hope it is clear.
Okay, sir.
Karamjit, huh?
Okay, sir. Okay, sir.
Yeah. So any other question?
Sir, I have my question in the chat box, sir. If my voice is audible.
You can see. No, I can see question. I want to detect food spoilage. Yeah, so algorithms, actually there is no fixed algorithm. It is very difficult to tell the algorithm name right now. But if you have less data set, right, the size of data set is like only 100 images or 200 images you have. So I will suggest to use transfer learning. And in transfer learning, like there are different algorithms or transfer learnings are available, like VGNet, ResNet, and GoogleNet, right? All these algorithms, like just try. Then using this transfer learning algorithms, you will require less GPU size, as well as if your data set size is less, then these algorithms will be effective. But if you have sufficient data set, then you can go for any variants of CNN algorithm. Nowadays, for object detection purpose, people are using YOLO a lot. But for you applying YOLO, you should have large data set. If you don't have a large data set, then I will not recommend to apply YOLO algorithm, right? And you can try with the unit also. Like unit is very good for detecting the precise output. People specifically use in medical imaging, because in medical imaging we need precise output, right? So there are different approaches. So just if you have sufficient data set, then try to apply YOLO. or this unit. And if you don't have sufficient data set, then I will recommend the transfer learning approaches. I hope it is clear to everyone, to you,
Yes, sir.
right?
Yes, sir. Sir, I was not able to find good
So-
data sets on these images. Where can we find a good set of
I
data sets,
understand.
sir?
I understand. Like this is the like a major problem in this domain. Like we don't have sufficient data set for like many of the application areas. So we need to work in a different way. Or if you don't have a sufficient data set, just use those images and apply data augmentation. So like using augmentation, you can generate few more images. So you can do that. So I don't know how many images you have, so it will depend on that thing also. So you can use data augmentation things, and you can like try that part also if you don't have sufficient.
Okay, sir. Okay, sir. Thank
Okay,
you.
now? Yeah, I will share slide with the organizer, right? So don't worry about the slides. I will share after around 1 hour. Any other question? Okay, no problem. I hope you understood everything. Then if there is no question, then we can wrap up the session.
Okay, thank you so much, sir.
Okay, then.
Questions? Yeah, it's the time for vote of thanks. On behalf of Department of CSE, Cybersecurity, Data Science and AI&DS, VNR-VJIT, I extend my heartfelt gratitude to our distinguished expert, Professor Sandeep Singh Sengar, Senior Lecturer, Cardiff Metropolitan University, UK, for delivering today's enlightening session on deep learning and its applications in medical image segmentation. Sir, with 10 years of rich academic experience and research experience, you have explained the fundamentals of deep learning and its cutting-edge applications in medical image segmentation with great clarity. Your insights into convolutional neural network segmentation techniques and real-world medical imaging case studies have provided our participants with valuable knowledge on how deep learning is revolutionizing healthcare and diagnostic practices. Sir, thank you so much, sir, for your valuable session.
Thank you, madam, for your invitation. So, good night, everyone. Bye.
Good night, sir. Thank you, sir.